Is the slide visible?
Yes, Arnav.
Is it visible, Guru and everyone?
Yes, Arnav. I can see your slide. Yes.
Okay. So good morning, everyone again. So I will start with Vmanage troubleshooting. So before we go to the Vmanage troubleshooting, there is a requirement that we may need to understand the Vmanage architecture first. So if we understand the Vmanage architecture, I think we will be good. We will be following logical step and taking scientific approach to solve each and every problem what is there in our hand, and that doesn't require any code freeze. So I'll start with that. So now this is the topic I'm going to cover. The first few 15-20 minutes will be on vManage architecture. Basically, vManage architecture, I will cover the microarchitecture because this is one of the exemplary node where we have implemented extensive microarchitecture level orchestration and monitoring and reporting everything. So then we will come to the component troubleshooting because as you know, vManage is not a single box containing many components, and each component has its own log files. Each component has require different approach for its own troubleshooting and getting the issue fixed. Now, come to the most important point. Few things we can troubleshoot, we can do a config change, and we can tune and we can solve the problem. But most of the things we need, most of the things to get into a stable code, we need upgrade. And then I'll come into few slides where I will define why we require upgrades and what are the things we can achieve when we are doing the upgrades and how does it solve our day-to-day problem. So now going for an upgrade, we have few consideration, best practice and checks to perform. So before upgrade, when you go for the best practice and checks to perform, those steps also contains a lot of troubleshooting, which will get you to a point where your vManage will be ready for getting upgraded. Okay. So best practice and checks to perform also contains vManage troubleshooting for different components. May it be infra, may it be Java application, or may it be your Viptela code. Why, I mean. So I'll start with vManage architecture, basically microarchitecture. This is your Viptela overlay. The what you are seeing is your SD-WAN fabric. Okay, all routers consider it as CH, VH. This is the Viptela overlay without your controllers. Now comes your NMS. Okay, let me click everything and then come to this. So I'll start with the vManage architecture. So anything you are seeing on the top is the NMS. I'll come to NMS later. Let's start with the Viptela infrastructure and secure control plane. So my NMS, my Viptela, my vManage architecture is sitting over my Viptela base code. When I say Viptela base code, Viptela base code is the base code which runs on VH, vSmart, vBond, and my vManage. So when you see the box where I have written vdaemon 1 to n, basically it will be vdaemon 0 to vdaemon 7. And this square is just the Viptela architecture which runs on every Viptela flavor, as I told. So our vManage is a micro-architectured box which composed and packed all the other applications over the Viptela base code. If you see the blue box above running over the Viptela infrastructure and secure control plane, that's our vManage. Basically, vManage use underlying Viptela architecture, and that's how the vManage is a component. It's a Viptela component. We have additional NMS or the applications running over there. And that bottommost box is your SD-WAN fabric. Now I will explain what our vManage architecture is. our starting point to go inside the vmanage or a outside world go inside the vmanage with wildfly. Formerly it was a jboss, and this wildfly is the application server. It's a red hat distribution, and immense development, tuning, and everything is contributed by red hat. So my application server is red hat wildfly what is running in the vmanage, and from outside world you go inside the vmanage, you interact with the vmanage, may it be with your apis, may it be with your web server access or ui, anything. Your starting point is application server which handles all your requests. Now this is the backend application server. Now comes to how you see the pages on your vmanage. Those pages are formed or developed using AngularJS. So AngularJS is the web client or is the front end of your application server, that is Wildfly Red Hat. And this AngularJS is a JavaScript based open source front end web framework for developing single page applications. All the pages you click, the dashboard is coming, you click the device page is getting loaded, you click network monitoring, you click template, all the pages what you see in the front end are developed using AngularJS. So still it's open source, but many the interested party contributes. Google also contributes in the development. Any Java freelancer developer can also contribute, but it's an open source. So we use AngularJS for our web page. The front end page you are seeing, those has many components. I will come to those, but the backend application server is Wildfly. That's Wildfly running there. Now, for a single node vmanage, the vmanage contains everything on a node where you are seeing here. Cluster, I will come later. So what are the mandatory things? Your application server needs a backend database. For us, we are using config.db is the terminology. From vmanage perspective. We are using the flavor Neo4j. Neo4j is one of the age of art. GraphDB, it's not RDMS, it's GraphDB, where relations are maintained between the graph nodes. So everything coming into on your network are all graphs for this Neo4j. We have a statistics and growing database which we are using Elasticsearch. So basically Elasticsearch contains all statistical reports from your network. Let it be interface related thing, DPI related thing, app route related thing, events, audit logs, everything. So we used to collect everything from your infrastructure, seeing in the bottom box, and store it in the statistical database. They used to convert the raw data collected from the network. We store it as a indices within the Elasticsearch. Now comes to the messaging and coordination. For messaging, we use Kafka Nets. Kafka is a history now. So for 20.3.2 or 20.3 onwards, the Kafka has been decommissioned. In place of that, we are using Nats as our messaging server, and that is also containerized here. Zookeeper is the coordination server. It's still there, and we are using Zookeeper since our the start. We have started our journey with Viptela 17 or 16. Only thing is the Zookeeper has also got containerized. So this messaging is basically the message server. We used to publish the message to the UIs, and that's how the UI is giving you the updates, like a site going down, out of sync, or a page getting refreshed, certificate updates, everything to the UI. Everything in the UI, that's the Angular JS, is published via the messaging server and Nats. And Nats on the backend, it's a pipe, it's a shared pipe. On the back end, it started getting messages from the config.db, and in the front end, it used to publish to the AngularJS to get you update. Now comes to the device config. So one of the most important part of the application server is we need to config the devices. We need to migrate the devices. We need to change the configuration. We need to have additional delta configuration of the devices. So we initiate those via application server, that's Wildfly, that give you a page developed via AngularJS. But what is used? It use basically NSO, that's Network System Orchestrator. And in turn, this network system orchestrator used to give you the or leverage you the part via which you configure everything and store the network element database from all your devices. So this also has the API integration between the Conti and TLF, what I will come to the later stage. And thus it will give you the give you the framework where you can have access to all your network device and you connect there and have your intent and action. This is basically the bridge between the intent and action from all your underlying database towards the database like config.db. So now this is the NMS box, the blue color box, which is entirely a Java code, which entirely runs over JVM. Everything what you see, the config.db, we used to have a Java code which basically use query builder to write the config.db cipher shell code, or the what you call the SQL kind of statement. We write it via Java. Statistics DB is Elasticsearch, but the application is again Java. Messaging coordination server Java. NSO is implemented over Java code. Everything is Java. So NMS, the whole NMS is running over JVM, and the JVM gives the virtual platform for the whole application server and everything what I have described. Now coming to the Viptela infrastructure. Viptela infrastructure is exactly same as I told for all the flavors. And in Vmanage, we have the cond component, which really give you the interface for through which you connect to all the devices, underlying devices. So Conti give you an abstraction layer for the whole network by storing the abstract database for your network devices, and thus the southbound network abstraction of Conti leverage you to onboard device in the Conti, maybe from any vendors. Like presently we are capable to do it for Cisco as well as Viptela. In future, this is open source TLF Conti component, so we are not we're going to cover it in details here in this because this is basically for vmanage, but this component will give you the abstraction layer of your network element as a southbound, and it has its northbound interface, which will give you all the API integration for the upper layer server. So in our case, my upper layer server is application server, via which you are using API calls for Conti, and intern Conti, as I told, will have a network abstraction for all your underlying network elements and contains the network element database NED. And thus the abstraction is present within the vmanage, via which vmanage is the orchestration, monitoring, configuration, and every day-to-day operation. I'll go to the next slide. Now this is the vmanage architecture component wise. Okay, so as I told, the entry point towards your vmanage to the vmanage is application server from a user's perspective. But as I told you, you can always have a SSH from your terminal that doesn't have a application server in the path. You are basically doing SSH into the Viptela code. But entry to the vmanage via UI, via web-based RESTful API, everything is through application server, that is Red Hat. So as I explained earlier also, here this is the web server RESTful client API. This we have exposed to the outside world. The YOLO box is exposed to the outside world so that you can have your API call implemented with the application server, where you can access the stats DB, the config DB, the system, everything from external server running any kind of code you choose, either Python or some other Ruby and all. So this is one of the interface MAPI we have exposed to the outside world, via which you do the application server access. And intern application server define all the API endpoints. When I say the API endpoints, it's basically three API endpoints. One endpoints will go to the vmanage system, that is the basic Viptela code. Another is the stats DB, where your everything goes to the endpoint and then query the stats DB, return you the stats related thing for DPI, application, app route, and other things like alarms and events. The third is Neo4j. You can have your Neo4j query via the web server client and RESTful API. So these three endpoints are defined inside your application server. Okay. Now, what application server do? How it gives you, what layer it gives you? It's a platform or a single plane of control from where you can do any network operation. When I say any network operation, that includes other components what I have defined in the last slide. But this is the point from this is the main server which basically orchestrates everything, and this is the starting point for the workflow. So from application server, you can do the security controller, you can do configuration management, device monitoring, the security zone-based firewall, etc. Or VH, device maintenance. You can have statistics for all your devices where you see click the DPI or interface uses or the tunnel uses, TCP optimization, everything. Do the SSH of the terminal again from the application server, because when you click the device, you can have a NCSS SD-WAN running there, which you give the SSH terminal via application server. You can run your operational command where you can get the routes, get the BFD status and all. The correlation engine is also working in hand to hand with application server, because all the event from your network comes to correlation engine. Correlation engine has a logic algo where it relates all the events and thus fabricate or generate alarms. And again, the alarms are consumed by the application server, because you are getting these alarms in the application server AngularJS web page only. Then it's come role-based access control. It's came into the newer version where you have roles, inventory management, because via application server, you are uploading the VS serial list, you are deleting a file, you are making a certificate invalid, put these devices into staging or into production. You have events. As I told, events are the feed for the correlation engine. So as it gets a feed to the correlation engine in the application server, also there is an AngularJS page where you can see all the events like BFD session downs you have seen, or like there is a traffic steering from private one to private two due to loss latency, jitter and all. You can control the multi-tenancy or the tenancy when you have a multi-tenant setup as a provider. When you log into the application server is the start point where you select the tenancy, and thus the schema for different tenant used to get loaded into you, and you are give the view for the different tenants. vSmart policy, the control policy, also getting configured by application server, because the page AngularJS page starts with this control policy will leverage you to do that. Device data collection is also via application server. So when you start the Wildfly, the app server, another module will get kicked in that is called DCA, Device Data Collection Agent. That basically goes every 30 minutes by default to every device and collects your stats data, and thus in turn those stats data is getting stored in the ES or the Elasticsearch, as I told. So basically every function, every process, every daemon what kicked in inside your vmanage is guided or orchestrated by the application server, because your operation, your maintenance, your monitoring, everything starts with the application server. Now, vmanage the control connection, the certificates, and all other things are vdaemon. This is legacy Viptela technology, which is already there as a middleware layer in the vmanage. Okay. And device communicator is netconf and SAP. So as I told, device data collection is a daemon which get kicked in when your application server or the Red Hat starts. But this daemon in turn use the technology of netconf to do a collection of data from your devices. So this is the underlying netconf infra which always get kicked in when you start the application server, because you collect data via netconf, and also you collect device, not the stats, but device data. When the device came up and down, you start a new thread, and that thread in turn initiates a netconf connection to your devices. So that's also a part of your application server, the netconf stack, what get kicked in when you start the application server. So the box where every function is there can be initiated, can be stopped via the application server. Now, the most important thing, maintainability. Okay, day zero operation is over. You have onboarded your device to the vmanage. Now, sorry. Now the main or the most important thing is that you need to configure the devices. You need to migrate the devices. You need to have a Delta configuration, and you need to do anything from your devices. Post onboarding, there is a template push automatically. You have already assigned a template, or you can onboard it with a minimum configuration and configure a full-fledged template where you are configuring the device. As I told you, the template push, all other every operation starts with your Angular JS interface. That is the app server's front end web page of through which you start your operation. So you can consider the panel, the box as your Angular JS front end web page where you start the operation for the template push. As I told, vManage application. This is the box. vManage application, you can think it as your page, what has been provided to you by the Angular JS. In the back end, the application server is running. What is Red Hat Wildfly? So this is just abstract layer or the workflow, how a template push is getting the success, uh, and what are the components in it. All these component already I have described. This is just to give you a view how you start with your web page, what is provided to you by AngularJS, and how the application server in the backend connects to all other modules and get this template push successful. So you can have device template, you can have CLI template, and then when you have device template and CLI template, basically when you click attach it, it's the application server which send it's the intent based CFS modeling. You have device young and everything. As I told you, the NSO. NSO used to have a northbound API to the CDB. CDB is again a components of the ConfDTLF. So as I told, this is not in the scope of this training to describe in more regarding the CDB and ConfD. But as I told that this contains the southbound abstract layer of your network devices, thus leverage you to configure the configure any devices of multi-vendor of multiple vendor. Let it be Viptela now and Cisco. As we told that we have an abstract layer of them, that is CH young devices. It can be VH devices. It can be any other device, and also if we implement the CDB on NSO. The thing is that device CH, here I have given an example of CH. It also contains confd. You also have a confd which takes the control of the CDB. So confd has IOSD intern, and it can be Viptela, it can be IOSD. Sorry, this should be CH oblique VH. Okay, ignore CH. I have done it wrong. It can be CH oblique VH. IOSD is the for CH, and Viptela is for your direct connection to the Viptela is for your VH. Okay, and a CH required a NESD IOSD, and then another API calls from NESD goes to the Viptela daemon. So there is the abstraction of all these devices there in CH device, and it can be VH device, and or it can be other device, and if this is implemented there. Now everything from the device and is getting coordinated in the application server. There is a persistent DB, which this persistent DB is our Neo4j, where we have graph nodes with all the config what has been present there, and then we build our configuration from the device template, CLI template, sending message a query to the backend database. The query builder will give build a query taking into consideration all the things you have selected by clicking a button or by writing it via a CLI. By click of each button, you know that you can't pass it via a simple message. That message should be incorporated from the device and send it to the DV in the backend. The query will come and give you the yang which need to be sent, and that yang comes to your vManage application in a XML format, and that XML format is again sent to the device via a netconf client. As I told you, the netconf client is getting initiated once you start our application server, because you have the DCA agent which gets started, and DCA agent used to communicate with netconf. This is just an abstract layer giving you the high level workflow, how our template push goes on, because this is the most important thing you will be looking for when you operate your network via vManage. Now, there are some idea I have given the idea for the vManage microarchitecture, what are the components, how we start our journey to get inside the vmanage via application server, and this is just a high level workflow for a template push. Now things may get wild, right? You try to do something, it's not working. That's why the wild things are, and we need to troubleshoot that either on yourself. You can do the basic level of troubleshooting, or you can contact tech. So getting into the troubleshooting, you have different components that I have described through. You have different approaches for different things, for different components. So now the things what you need to look when you things what you intend to do, either a template push or a device onboarding or a certificate update, anything for Viptela functionalities doesn't work for you, you have a lot of logs. So I'll not come into vmanage. I will not go inside this folder that is /nms. I'll go for all other inside varlog. /nms is the folder which contains the logs related to all the Java applications that I have described in the first slide. The big box NMS box lying over your Viptela code is the these all Java applications. So those logs will be there inside /NMS. So that I'll cover in the next slide. But inside var log, you will have debug log and query.log. This will give some idea if Neo4j is behaving wild. And now saying Neo4j is behaving wild, Neo4j, as you know, can be working as a standalone or as a casual cluster. Neo4j not working in a casual cluster can also give you some the Neo4j not working in casual cluster. We have no idea why it is not working. I can't do template push, or I can't even log into my UI. In a cluster mode, you will clearly see what's happening in the casual cluster when you have query.log, debug.log. You can see leadership changing and everything. Now, cluster related things also will be there, as well as simply looking into the debug log, query.log, you can easily see the transaction going on, the time taken for a transaction. Is some query getting failed or delayed, getting terminated? Neo4j out in upgrade, I have given a star. So there are three others. Neo4j in out and upgrade.log will also give you logs related to Neo4j when you upgrade. And in and out log give you the log of Neo4j when Neo4j is getting connected from your Wildfly. As I told you on the first slide, my Wildfly is the application server in the backend. It has to connect it to Neo4j. Neo4j schema need to get inserted in the Wildfly, because you can't do some operation from the front end until and unless you have a connection to the backend. So for the backend connection, it's a Bolt. Neo4j exposed a Java-based connector called Bolt, what has been taken care at the, it's our Bolt Java-based connector, what the Java-based Bolt library, what we used in the app server. So those Bolt related log or wrapped related replication log can be seen in the Neo4j Neo4j asterisk.log. This contains three files. Kafka.log. This is for older version. Now this is not there. These are the messaging servers. This is the messaging server what we have used earlier. So you have to go to this folder for Kafka oblique messaging. As I told, the YOLO at 20.3. Here, messaging, vmanage messaging logs will be there for NAT streaming. These are the NATs are the NATs is the present technology what we use for messaging, and it starts from 20.3. Vmanage server.log are the generalized log. Okay, sorry, I missed this slide. Okay, I suddenly moved into NMS. So ignore that what I told about NMS. So vmanage varlog temp vddigger kernel message vsyslog auth. These are not Java logs. These are non-Java logs, and these logs are for Viptela functionality. I will go to the next slide, or I just described what are there in the inside NMS. So ignore that. First, let's concentrate on varlog, temp, vdebug, kernel, message, vsyslog, auth, NCS. These are all Viptela functionality. The vdebug will give you all the error message of vdaemon routing certificate. So vdaemon will give you things like your VFDs, your certificate not coming up, your control connection coming up and down, your events, your up down events with the control connection, everything, routing certificates and everything, all basic Viptela functionality. Kernel is the underlying log from the kernel where you have built your VMs. So anything like hung in the kernel or a process consuming out of memory order, you have GC allocation failure and all, those can be inside the kernel. Messages are general message logs which will be there for everything common to the Viptela daemon. vsyslog are the syslog, auth log are the authorization log, and you can see it inside var log. All the auth log will give you authentication failed, net admin logged in, Viptela admin logged in, denied, invalid username. Everything will be there in auth log. And NCS will be the log for the NCS. NCS is the module what has been designed inside NSO. I described the NSO in the first slide. So NCS is the model, basically device discovery and getting the config and given a southbound abstraction of your device config to the NSO is done by NCS. So all the NCS related log can be seen inside varlog NCS. Now, as I covered accidentally up to Kafka, I told that messaging on NATs is there for the vManage messaging. This is containerized new messaging system. What's there from 20.3 onwards? vManage server.log. This is the main file you need to look at when things are not going good. When things are not working, you have to go to vManage server.log. So here you will get every general log for all the Java-based daemon, but for this, you need to your app server running. Without your app server running, there will be nothing logged inside the vManage server. So when your app server is running, you will get everything regarding NATs, regarding Neo4j, regarding your connection to the Zookeeper and all things will be there logged inside the vManage server.log. Now, vManage app server.log, this log started from 20.3 onwards. This is basically the log which says the moment you switch on your application server, the Wildfly, everything the Wildfly do until the WAR or the web archive get deployed. Like the moment you start request NMS application server starts, immediately on different windows start rolling your vManage app server. You will get to know the moment you have started request NMS application server start, basically a SV script will trigger the Wildfly Java process. The Java process is getting triggered, will give you all the insight what it's doing unless and until it get deployed. So as I told that it's a WAR file which will get deployed. Until then, you will see everything in the vManage server. The WAR file is the web archive developed in the web archive for the Wildfly or the application server. So these are few of the troubleshooting few logs which will give you clear insight into what's going on and how to handle those. Coming to the next slide. Now inside NMS, as I told, these are the things for what, and you need to see what is there. Now more in more application specific logs for vmanage elasticsearch or the statsdb. If you are running statsdbs on that node, for a cluster you may not have logs inside the nms vmanage elastic if that node is not running your statsdb. But for a standalone, you will always have a vmanage elastic. For a cluster, you have to go to a node which you have subscribed for statsdb. Then you go inside the nms vmanage elasticsearch and see the statsdb logs there. Here you can see the elastic cluster log. So we inside this directory, when you go to the elastic cluster log, it will give you a clear insight of your out of memory happening due to elastic cluster, which you when you have extensive or external API calls, which is making costly query to the statsdb. So this is a start point for troubleshooting when you have a problem with the statsdb. These are the vmanage server rest log, all API calls. No, not all API calls. This will only have all your post and put calls. When you have an external tool running over your vmanage or you have developed a wrapper, You may sometimes see that, okay, I have sent a post with a body, but I'm getting 400. Okay, not getting 200. Nothing is written, no JSON body. Or I may get a 200, but my JSON response body is blank. Where to start? No idea. So then you have to go to vmanage server REST API.log. Here in this log, you can clearly see the post or the put sent by your external code and how it is getting honored, whether it is getting honored or if there is an error. There may be an error in the JSON body, there may be an error in the URL you are sending. So those things can be noticed here inside that. There is a problem in Zookeeper. You will get it in the Zookeeper, but again, for the messaging, you go to /nma Zookeeper. This is 20.1 and before, means all the older codes. Now this is not there. The path is not there because the Zookeeper coming under a container manager. As I told, as we are growing and we are coming with newer codes, my apps are going inside containers so that any apps behaving wild can't consume the whole memory of my VMs. As I told that these are simple Java apps before, where XNS and XNM are the binding what I have given for the memory consumption. As we are developing newer code, we are going towards newer version. More of the apps are going inside a container. So this Zookeeper is not present with our newer codes. You have to go inside container manager. Vmanage server statistics, these give you the per device stats processing. So when you say per device stats processing, it's, as I told, there is a data collection thread which starts with the Wildfly, which used to collect the data from its device. So after collecting those data, there is processing happen, and thus the raw data is converted into your indices. That can be seen here. Vmanage vdaemon, NMS vdaemon. This is the vdaemon what is taken used by the NMS, not the Viptela vdaemon. The vdaemon has a northbound interface what is used by our NMS applications also. That can be seen here. Vmanage server device config is the log which says you while the template push what happened. You can see the whole template going there. Is there any fail, bad CLI, and all those things. And vmanage server device config template is this template processing. When you form a template, when you submit it, there is a template processing happens. And as I told, the template processing is basically the workflow what I show, and which require extensive DB query, and there are DB query results from the backend database. Those can be seen inside vmanage server device config templates. Now comes to the question. I will cover few slides regarding upgrade best practice, but the question comes is that why upgrade? Okay. So why upgrade? And most common thing for our vmanage, what you may have faced is that upgrading solve your problem. Coming to a stable version via upgrade gives you a new features, also stabilize you, and also solve your older problems what you may have faced from different components. Why upgrade? The first point, bug fixing. Day in, day out, you may raise a tag case. We may identify a bug. The bug may be in an older code. We know that we have committed it and fixed this in a newer code. Basically, these, as I told, these are Java apps. Lot of Java apps running over Viptela based code. So bug fixing is required for that. And the best solution for that is go for an upgrade and fix the bug with the fixed code. Software reached EOL. This also is a point which you should consider and do the upgrade of your vmanage. Because end of life software, you hit a issue, tag identify it's a bug, erased a bug, will not be able to fix it because as it's end of life. So that time only if it already fixed in a newer code, you have to upgrade. Add up new feature. With every new vmanage versions, there are new features. There are not one or two, but a lot of new features. I don't have the scope to cover 20.6 here, but with 20.6, if I don't know if you have used, you have check the flavor of your UI and all. We have a lot of flavors. Like when you came to 20.3, we have Colo and all these things. So to adapt new feature of you have requirement for the features what we introduced, you have to upgrade for a version which give you these features. Now comes to move into a stable or recommended release. Vmanage upgrade, if not driven by the above three, you should come to a stable or recommended release because 23, 26, these are few throttles which we recommend to come because these are long-term release. These are recommended release. And there will be always rebuilds happening on that, and there will be always bug fix going with each rebuilds. Now consider it like that. Your vmanage is on 24 or 25. You have a problem. You have a problem. We identify a bug. As I told, still not UL, but if those are short-lived releases, we don't have a plan to have more rebuilds. But yes, if you are in 23 or 26, no matter after 1 year or when you hit a bug on those releases, we will always have rebuilds and plan to fix those until we announce anything explicitly. Now, few of the consideration you should have once you are going or taking a decision for the upgrade. Few of the upgrades are minor upgrades, like as I told you, you are in a throttle which is already a long lived, but you have a bug in 23.1 and you have to go to 23.4. You are in same throttle. Architecture is same. We don't rewrite architecture level code when you have a upgrade from 23 to 23.4. Limited number of changes, there are bug fixes only, limited testing required because we have compact regression and all running when we are just upgrading inside one throttle. Major upgrades are something you need to think about. You need to do some homework before you go because major upgrade like something 23 to 26, 19 to 23, it can give you change in behavior. It can have new feature. It can have architectural changes. It can have code rewritten for a whole new module. So you need to go to release note, read everything, decide wisely when you are going for a major upgrade. But major upgrade through a stable release is always a good practice. But as I told you, you have to go and read all these things before you decide that. Increased number of bug fixes when compared to the maintenance only, validation recommended. You need to validate it before you upgrade. So these are the major upgrade, minor upgrades, and EOL recommendation is always there, adds on top complexity of multiple state that can be required because normally we announce EOL for the older versions, 17, 18, and all. And from Cisco, it can. I think you have heard that we communicate that come to a stable release. Come to a stable release means comes to a long-term release where we have star marked. So suppose 18.3, what is EOL? We told you the come to 20.3. It's a throttle which is marked as long live. We have star marked, and we will always give you fix with new feature. Always give you fix. We'll always have rebuilds. For that, as you are in a older code and now you are on 20.3, you can't do direct upgrade. There are complexities where you have to consider the multiple steps of upgrade could be required because those time the Elasticsearch, Neo4j, or the Java apps what we have there may have changed. They may have gone through lot of delta changes, and lot of delta changes can't be accommodated suddenly with the delta operations. For those EOL recommended upgrade to a latest version, I will request all you guys to have a tag cases. So tag validate this and give you the multiple step if required, and thus you come to a recommended or long-term throttle. Best practice, I'll cover few of the sites after this. So there are few best practice. These are just the note. These are few points you need to consider, like controller to edge compatibility. When you are taking a decision via this decision tree, this and this, you need to consider this also. You know you are running VHCH. The moment you upgrade your controller, that time you still have your VHs and CHs running to your older things. You need to see the compatibility version first, that what are the VH and CH version, what are compatible, that is n to n-1 compatibility. When you upgrade your vmanage to 19.2, just see whether 19.2, 16.12, or you are 23, 73 will definitely there. Is the compatible? Read the release note, important notes in the section. Okay, with release, when you read the release note for the vmanage upgrade, there is another point. you are coming to a newer version, 23 or 26. I will not consider 24 or 25. While you are downgrading, while you are downloading the image in the CCO side with the click of a down button, there are disclaimers. I'll emphasize all of you to go to the disclaimer and check what disclaimer is there with this release. Okay, so there are many CCO release where we put disclaimers. You have to note those things. Upgrade sequence is always vmanage, vwan, vsmart, and vAges, cages. Pre-download the package as server before the upgrade process. Upload to the vAge after controllers are done. Ensure backup has been done recently. So before you, sorry, sorry, before you decided to upgrade your vmanage, backup has been done recently or not, you need to think about this. If you are on a on-prem deployment for cloud, uh, you just send a mail and just confirm whether backup or the snapshot is getting done in a routine manner or not, because something goes wrong while upgrade, you have a way to roll back from either the snapshot you have on your own data center or the cloud ops taking snapshot. So activate the image before you make it as default. These are the few best practice. Use CLI for cluster upgrade. This we have already documented in the CCO page for cluster maintenance and cluster upgrade. The CLI for the cluster 6 node 3 node of cluster upgrade. So use vmanage. As I told you, when vmanage app server via AngularJS is giving you the page from where you start operating everything on your network, maintainability, operation, day zero, day in, everything. So use vmanage as your Vmanage updates or upgrades. If using CLI, make a copy of the config, show running config, this, you know, all these things. This is from device specific things, not a vmanage specific things. But as a best practice, I have written these two steps. Downgrades. Please note, vmanage does not support downgrades. It can be within a throttle. You are going from 23.2 to 23.4, and it's the same throttle, same code, only bug fixes. Still, there is it's not supported. So once you upgrade, you want to come back to the earlier version. The only way is via a snapshot, as I told in the last slide. So when you upgrade, just take into consideration that you are taking snapshots or cloud ops is taking snapshots, and you have those ready. So alternates are revert to previous snapshot, activate older image, fresh installation, and restore DB. If you don't have a snapshot, also you can easily take your DB backup and keep somewhere safe, so you can restore it with the backup DB. So that time you will lose the statistics, but yes, you can have all the device onboarded, template, policies, order logs, and everything there. Now edges can install older config. Edges can install older image means for edges it's a little bit different. Though it's not in the scope of this class, session, but I have just added edges. It's little different. Configuration can be lost when you go to older image. Older image you can go if still there. It's inside the device. Means you have upgraded the device from 16 to 17.3, you can upgrade. If 16.12, the device is still there, you have not removed, but configuration will be lost. You can reactive older installed image, configuration will be frozen at the upgrade time. Restriction apply on older than 18.4.5 images. So there are few restriction already we have documented in the CCO page. For older images than 18.4.5, even still the image there inside your box, you will not be able to revert it back or activate the older one. Now, your best practice for the vManage software also include a phase which is known as planning, which you need to do before the maintenance window. So best to plan upgrade process in advance. Identify the test scenario. You are going to upgrade your vManage from very old code, which is already UL, and coming to a newer code. So you need to verify the things after you upgrade to the newer code. This basically is the vManage health. vManage health means your VM health, CPU, memory utilization, interface utilization, idle time, and everything, the nice and all. Template push, the basic template push, just change some of the comments in the interface and do a template push. At least the workflow is broken or not, you get to know. The router present at the edges, Before you go for such a major upgrade, you take the snapshot of the pages where you see the devices. Post upgrade also see the devices. Basic traffic flow also just check where you have a UI which shows you the traffic flows for the IPsec IC or DI and all those UI also you access and check whether those basic traffic flow is still there or not. Document the process preliminary activities are like software download, copy to repository, test template push test. Just document what you need to check post upgrade checks routes traffic everything. So there is a UI where you can go and do the all OMP routes, check all BFD routes and everything. So check those things after a major upgrade also. These are few of the steps again for the planning. Maintenance window steps, stop all configurations, stop all third-party monitoring, trigger DB backup. As I told you, if you don't have a snapshot, you can always have a DB backup and trigger just spin up a new instance, do restore the DB from your backup, and you can move ahead with all your devices onboarded already there. Copy the DB to the external repository, health check what I have already discussed, software upgrade, vmanage, no activation, just upgrade, no activation on a maintenance window, do the activation. Optional cluster is the service stop. So this is the cluster upgrade. This is also we have documented in the CCO page. There are few more things for a cluster upgrade. As I told already, it's a CLI activity, but few steps need to be taken care because now you can move from older images to 26. The concept of clustering in 26 is totally different than earlier, and this session I'll not be able to cover those things because that's a big chapter. Vmanage activation, optional cluster, config DB migration is one of the things where you need to consider when you have a cluster. This is also CCO'd or documented that while you upgrade the cluster, DB migration or DB upgradation is required from certain version to certain version because the Neo 4J version itself got changed. Initially, we have 3.3.9, now we have 3.5.22. So when a cluster is upgraded, you have to trigger a Neo 4J upgrade in one of the node. In turn, that will upgrade the Neo 4J in all load. That is a separate step. It's given in the CCO page. Upgrade to vBond and vSmart, activate and vBond and vSmart after you upgrade your cluster or a standalone vManage. Planning, best practice planning. So these are enable any third party tool post your upgrade and you have done all the checks what I have already described in the last few slides. Validate service across vmanage. This is for cluster. When you enable upgrade your cluster, you know what are the configuration of your cluster. 3-node statsdb, 3-node neo4j, messaging server running in all for 20.6, no messaging server in any of the statsdb. So those screenshots you take and post doing the cluster upgrade, again come to the cluster management page and validate that cluster configuration is intact. Validate overlay routes and traffic, rollback decision points. After validating everything, you have to come to a point where you need to decide whether it's go ahead and roll back. As I tell, rollback downgrade is not an option, but I have told what are the option you can go to the older version via snapshot or DB recovery. Health checks and basic troubleshooting. Health checks, I have just touched the point. You have to do the health check of your vmanage. That's a best practice before you go for your cluster or standalone upgrade. But if you do the health check, that also includes the basic troubleshooting of your vmanage, and you can catch day-to-day problem what you are facing with your vmanage. Basic health check. You may be coming to a newer version 20.6 via step upgrade where you are still running on an older version like 19 on 20. So the OVA usage is due to the old OVA uses. We initially support other types of driver, but now the support has gone for the new OVA. So these are the basic health checks you need to do before you upgrade your cluster or your standalone vmanage, which is on-prem. ETH tool minus I ETH0, check the driver. ETH tool minus I ETH2 for cluster, check the driver. Partitioning on-prem. this is one of the most important steps you need to do before you upgrade to a newer version where you have started your journey of the Viptela with older codes. So for a older codes, this boot partition is always less than 2 GB. Here you can see it's 3.1 GB, 2.3 GB is free. And the code what is running inside this vmanage is taking 868 MB. So this boot partition, you are not you don't configure or tag can't configure this. It is from the OVA file when it get spinned up on a vmanage. So for older OVA, the code is such that you allocate less space for your boot, but for a newer version upgrade, your image size is immense. It's 868 for an older code. Now our size has gone towards 2.9 GB, I think, with 20.6.2, 6.1. So it basically required a huge space in the boot partition. So that's why there is no direct upgrade. Open attack case when you are coming from an older release to newer release, because this is one point where the upgrade fails. And we need to come to a gateway. 20.1 is a gateway for the newer technology from the older one, where we have a script which decides the boot space and then spin a new boot space which is of a larger size and thus accommodate the newer image. So this is one of the basic health check for the on-prem cluster as well as your standalone before you decide for a upgrade from an older to a newer release. Definitely df minus k need to be checked, either rootfs rw. There are few older codes, there are few bugs where the rootfs rw will be filled up because few of the logs are getting populated in this. Just check your third partition, that is the dev sda OPT data. The OPT data contains Elasticsearch, Neo4j, admin tag, core, dump, everything you do here. So also check that whether there is a space there or not, because if space is not there, you will not be able to do the upgrade, because with each upgrade your db size may increase or the elasticsearch size may increase, and if space is not there, the moment you upgrade, your vmanage will not able to collect, your vmanage memory may shoot up because elasticsearch with a newer version will go into a read mode. So it's the best practice. Look into the boot space hda1, look into the rootfs hda2, and the third partition dev sda. So Dev SD is the third partition which always have 10 terabyte for our newer releases. What we recommended with DPI and all, but DF minus K is mandatory before you go for upgrade and checks on this. You will have only three physical mount point: HDA1, HDA2, SD-WAN. So this is the output I have taken from older where you have hard disk. Nowadays we don't support hard disk. Okay. Memory sizing. This also you need to consider, because as I told, customers, partners may decide to come to a newer release from a legacy Viptela release what they are running, like 18.2, 17 or something, which is really, really old. The requirement for those are totally different that time. Now the requirement has changed. So you need to consider memory sizing. If it's not there, go for a memory enhancement and then upgrade. You can simply upgrade to a newer version. That will fail, or the vmanage will hang. You will not get the things what you vmanage intend to give you. So check the Cisco SD-WAN controller compatibility matrix and server recommendation. I have pasted the two URL which basically gives you about the compatibility matrix for the server recommendation for 20.6 and 20.3, because these are the two major releases what we are tracking now, and we are telling this as a long term releases already star marked. So you just go there and check. Now, coming to the newer things, already DPI is enabled in 120. DPI is enabled, and for on-prem, you require 128 GB RAM when you are coming to a newer version. This was never the requirement when you were on 19 or 18, and so you may be running a node or a cluster in all node with 64 GB RAM. Consider this before you go for a upgrade to a newer release. So with DPI enabled single server, we have already documented less than 250 CS or 32 GB. 32 GB is the ingestion rate or DPI. What should be the your size? less than 1064 GB, what should be? Is it single? And 1500 64 GB is the size of the RAM. But again, go to the URL I have given, because it will give you with number of devices what should be the ingestion rate. Things need to be considered is the ingestion rate. If you have less than 250 edges, but you have 100 GB of DPI ingestion rate, things need to be checked in a different domain. And you have to consider for a cluster, maybe because you have less number of node, your DPI ingestion rate is huge. Okay, so let's just revisit or visit all the URL before you take a decision to upgrade your on-prem controllers. Let it be a server, let it be a single node or a cluster. There may be a decision point after reading the server recommendation, which will give you a decision making a pointer where you have to move to a three node cluster when you are going for a newer release, because in newer release we have a lot of new processes like rate limiters, cloud agent, proxy servers, elasticsearch new version and all. So memory requirement for newer release is totally different, and the recommendation for the server recommendation for newer release may be different for your old releases running 17 or 18. Now coming to the DPI disabled single server, it's quite straightforward. 1500 2000 device is 64 GB. More than 2000 device is 128 GB. Still, if you don't run DPI, we required 128 GB, because memory is consumed by the NSO and the netconf when you have lot of number of devices, and we do data collection. So again, DPI disabled or DPI enabled. Coming to a newer version, you have to go to the URL I have pasted to come to a decision tree what you need to do. Coming to the point, if you have heavy API or DPI uses, you may push towards the upper limit regardless the X or the VH count. As I told, I have given here the VH count. This is not just a single consideration or single domain which should give you a decision whether to go or stick with a single node or go for a cluster. You have to consider if your DPI usage is more or the ingestion rate is more. Now there is another dimension what you should also think. You have a DPI which is still low, and you have a range of Vmanages which is still within your limit like 250, but you are using heavy APIs. Heavy API means, as I told, you have built a total reporting and monitoring tool over your vManage, a wrapper, a total wrapper which gives you a new pane of glass for everything, reporting, monitoring, DPI, and all other things, SNMP and all. So you are using API. So those API are also resource hungry. Resource hungry is not that much CPU cycle what it consumes, but yes, it can consume your it can consume huge memory when you are doing costly API, especially bulk aggregate. This session I will not be getting time to cover those the API best practices, but just consider one thing: before you design your third party tool or a wrapper you develop over your vManage or by giving contract to any of the third party developer, please consider bulk API and aggregate API as a costly resource hungry entity, because those will consume huge memory from vManage perspective, because bulk API has to collect the bulk data from the statsdb, and if you are using a timestamp that is 1 hour and contains millions and millions of records, that will break the vManage operation itself. Also, aggregate API, if you are sending heavy API, is considered the why I wrote heavy API. Heavy API means bulk and aggregate API. Aggregate API, when you form a JSON body with if then else on all the columns, you are doing many hits to the statsdb. You have put some conditions. Those conditions may not be fetched from a single indices, but it need multiple fetching, sorry, or query to the backend database to give you the aggregate body or the JSON body. So please, a caution, or just consider the design, all the documents, get a best practice from Cisco before you design your APIs for a vManage post upgrade or pre-upgrade. This is independent of upgrade. Most probably you have to decide how you are developing your third-party tool with the API interface. The API interface, just get it validated once, so that as I told you, memory hungry. Bulk APIs and aggregate APIs are resource hungry. These are the on-prem health check, as I told. DPI enable, definitely you read 32V CPU, DPI disable 16V CPU at 250 devices, 30V devices, anything else. As I told, if you have DPI disabled also, there may be a question why I required resources. Resources means memory and CPU. Yes, you required, because if DPI is disabled and number of devices are more, you have resource hungry netconf, you have resource hungry data collection agent working there, you have NCS which has to discover a lot of devices. So scale network without DPI also required resources. And as I told, there are URLs what I have given there. You need to follow those URLs before you decide for the upgradation of your ESXi or the hypervisor. Watch out for oversubscription. Okay, as I told you, we don't support oversubscription. If you are dedicated, we need dedicated CPU and wrap. Don't do 3:1 oversubscription, because that is not yet tested, and we don't recommend any of the oversubscription from the VM level. I have seen people have oversubscribed their CPUs between number of VMs, both Viptela and non-Viptela solution. So my resource uses will always go high at 30 minutes, because I used to have a lot of data collection going on. So combined resources going high at 30 minutes, exact at T plus 30 and all, have a problem if you do have a oversubscription. Inter-cluster communication link, our recommendation is 10 GB. This is for cluster. When you have an on-prem cluster in AWS, we are taking care of your cluster communication and all, because we maintain those things. For on-prem, you need to consider it. Inter-cluster out-of-band interface should be connected between each node dedicatedly. No port channel, no redundancy on that. Means you can't have teaming or port channel, all other things, no, nothing. It's just the dedicated 10 Gbps link between all your VMs where you are going to run the cluster nodes. So this is another recommendation, and you need to consider that before you move from a single node. There are cases where customer move from a single node to a 6 node or 3 node. That's a vmanage expansion which need to be there, which need to be taken care, because of the need of resources with latest upgrade or more DPIs. Just give me 1 moment, let me take a glass of water. Coming to the next slide, ID type. As I told, HDA1, HDA2, these are all hard disk. Before you upgrade, this may cause a problem post upgradation, because we 20.3 dot or 20.3 we have added the CUSI support. Older releases may work on ID, best to change on upgrades. So with latest releases, we don't recommend to run on hard disk. So you may be again on-prem deployment. You may have started your Viptela journey from 17. You're still using the hard disk. While you are taking a decision to upgrade or come to a latest version like 23 or 26, you need to consider this. You have to change the HDD to CUSI devices, or SDA. This is one point you should note before upgrade. This is one of the important health check. Now, stats TB indices health. As I told, to decide whether you have to go for upgrade, software upgrade, and post software upgrade, you are going to into a single node, you are going to continue on a single node, or you are going to go into a decision where you have to decide whether I have to move to 3 node cluster or a 6 node cluster. And before upgrading the Elasticsearch, you have to take care of the health of the Elasticsearch in your older version, because post upgrade Elasticsearch also getting upgraded and may not come up if your older indices, what has been formed by the older version of Elasticsearch, is not green. So next API call will give you the size of the indices, which will give you a which will give you a pointer whether to take a decision for expansion from single node to multi-node or not. But this is one API call you need to trigger before you upgrade, to check if your indices what has been formed with the older version are green or not. If it's not green, there can be a problem when you upgrade, because new Elasticsearch version will not be able to come up when the indices are amber or red. This is index health. Before upgrade, you need to check. And this is index health alternative access. Here you will see the size as well as the color, if the indices are healthy or not. So this is local host. You use local host in case you are a single node. Use the IP of your out of band interface when you are cluster, because your 9200 port don't listen to single host. When you have a cluster, it listen to the out of band interface where your stats db are running. And moreover, don't use the out of band interface for the node where stats db is not running. The stats db is running on nodes, use that interface cat indices, so it will give you the indices. You will see the size of each indices. Moreover, here you just concentrate on the size. The color. Here it's green. Any red, any amber, just open a tag case. Oh, we need to take a look at those indices before you upgrade. Going for a upgrade with index is red or amber is not at all recommended. Look out for Neo4j logs also if you have still errors in your Neo4j. As I told, Neo4j in, out, death, and other logs are within NMS, as I told in the last slides. So you have to look out for errors in the Neo4j, because with upgrade, as I told, from older version to newer version, you are upgrading your Neo4j also. You are upgrading your Vmanage. In turn, you are upgrading your Neo4j. That is the config DB. So look out for Neo4j errors, like this kind of errors, null references, error works, and this is just an example I have captured for a node where there are some Neo4j errors. So before deciding to go for a upgrade, look out for this also, because TAC need to have a look, or we need to have a look upon what error is there in the Neo4j, and thus solving those error, Neo4j, bringing back the Neo4j in a healthy condition, we have to decide for the upgrade. This is the performance-wise rough view of your Neo4j. As I told, this query log will give you a number of time the Neo4j is taking for a query. So these are the planning. You see, this is a query. Bold session. Bold session is the Java bold session. What has been initiated from the app server means there is a query you have initiated from your AngularJS web page via the Bolt. Bolt is the Java driver for the Neo4j. And you can see the millisecond it's taking for the query to getting executed. Okay, if some queries are taking huge time, no problem. But before upgrade, you just consider the Neo4j query.log and just look out if you have number of thousands and frequent queries which are taking heavy times. Okay, this huge time may cause a problem on your Neo4j upgrade. Your cluster have a problem, because when you go for a newer version, Neo4j need to be upgraded, but as your Neo4j query are taking a lot of time, this need to be troubleshooted before you decide for a Neo4j upgrade. You can see in the query log, match vmanage system device node with sorry system device node and all. What are the queries going and how much time is taking? One or two in the whole log taking more time is expected, because that time there may be a CPU spike or memory spike. But if you have lot and lot of these things in your query.log, just look out who is doing this query. You can see this a bold session means it's our app server sessions and the query has been initiated from a AngularJS web page. And this is taking time. Okay, this is device configuration. Someone is doing the device configuration. Here also you can see Neo4j Java client and the whole query I haven't captured. This is also a bold session. Okay, this is also something what has been initiated by my application server. Go look into this query log. There are a lot of queries which is taking a lot of time. Let's there Cisco involvement. Let Cisco decide whether your Neo4j is working fine. First Neo4j look out for this, then Neo4j look out for this, and then decide for a upgrade. Now, no pending task. This is one of the most important thing. Big network, scale network has a lot of NOCs. NOCs has a lot of operators which work 24 into 7. Different people have different jobs like upgrading of VHS on bulks, template push on bulks. So they are really very difficult to sync with all the NOC operators and get into a common page that nothing is working on your vManage. So better when you decide for a upgrade, you just check if there are pending tasks. If there are pending tasks, please don't go for a upgrade or don't trigger the vManage upgrade until and unless the task has been finished. Now there may be a task where 200 thread to there may be 200 device upgrade initiated from your vManage by some NOC operators, and you have a maintenance window which need 3 hours downtime for your vManage upgrade. You can't postpone that. So in that time, don't just simply upgrade before looking into the pending task. You see there are pending tasks for device upgrade still there. Okay, so then you just kill the task what is there pending or what is there stuck. Because if you don't kill this stuck, there will be a problem. Or you may lose half-baked configuration in the device, or half of the device got a upgrade and it went to a reboot. After reboot, it came to a newer version, but as the vManage went into an upgrade state, it's rebooted. The upgrade confirm is not given, and the device will roll back. So we don't want to get into this kind of situation where we are in a half path of doing template push or upgrade, and we suddenly start upgradation. So click on that red box. You will see the task. There may be a lot of tasks which are still pending and which may require hours, and your maintenance window has arrived. Please terminate all these things. So how to terminate? As a cluster, you can use any of the server IB, data service, device, action, status, task. You can see there is process ID, reboot of this, tenant ID, this, start time, this. So this process ID you just capture. This is the task ID, reboot, and then the alphanumeric or the string. You can have template or other things, upgrade and all. So you need to clean up. You can't clean up all at a bulk. You need to clean up each before you decide for a upgrade. So what you have to do is that server IP, data service, device, action, task, clean, then the process ID. Process ID you copy from reboot and then the string. It can be reboot, it can be any other things, templates and all these things. So this is one of the best practice you need to follow. Here you have to do the cleanup of the task before you upgrade. So points, I think you have noted the points. What are the things? This best practice or the health checks before upgrade will also cover the basic troubleshootings for your vManage. Now, there is a problem. This is one of the things we have noticed internally and we have recreated, and we know why the reason only applicable for 20.3.3 and 2 or 1. 1 we not considering because that's not there in still. So 20.3.3 or 2, there is some options where authentication types are not there for a user. It's only netadmin and vvasu. So if you see AAA users, there will be no authentication type. So when you configure it via CLI, the CLI allowed you without authentication type, and there can be a user. Now, when you upgrade your vManage to something where this is fixed, means this user is not allowed, a user will not be allowed without authentication type. You have a upgrade failure because this 23.4 includes preventive fix. This 23.4 doesn't allow your user to have this kind of things without authentication type. So just a best practice or a precaution, go check show AAA user in which version you are. If you are having some kind of user which is having an entry without authentication type, this is not supported in your latest version. So you have to delete this user or modify this user and give them a consent token based or just write password with. This is a user we have created, not the OVA file or the spin up of the VM has created Cisco TAC R1, Cisco TAC RW. That's why they are consent token based. This is created by us. So netadmin give a password based and then upgrade. Don't upgrade when you have a blank entry like that, because the latest code don't support this kind of user and your checks can fail. Now all services are running. Yes, definitely you need to check this one. True are for the services on the node which you intend to run on that node and what's there configured as a true inside the server config.json. So you just see what's true is running or not. Enable true running. Enable false not running. This is also okay. Enable false not running is okay. Whenever something is not running but enabled true, that's the point you need to consider, and you can have a tag case for that. Or you can also go and check the logs what I have already described for that application and check why something is true but that not running. Check the vmanage server.log, check the particular application.log. But yes, this is one of the best, this is one of the checks you need to do. This will give you a troubleshooting steps. This is the start of your troubleshooting for some application also, if it's true but not running. Now, as I told, there will be a decision you need to make whether to move to a 3 node cluster or stay in 1 node or go from a 3 node to 6 node or 1 node to 6 node. So this is one of the API which will give you the estimation of your per day DPI ingestion rate. And with new server recommendation and sizing, we have mentioned everything for how much DPI ingestion rate, what is the requirement of server, the number of nodes and other things. So this also you need to consider. Just run this API from Postman or go to URL or go to a browser. Just run this. It will give you everything in JSON format. Just capture 1 day DPI ingestion rate, go to our server recommendation page, check what need to be done before you upgrade, because the server recommendation page for 23, 26 and latest version is different from what server recommendation was there before in 17 and 18. So as I told, you have decided to come to a latest version from legacy Viptela, you need to check this and decide how you are going to expand your vmanage, whether 1 node 6 node. This is one of the general checks. No, you do Ntp synchronization, no secret about to expire, all controllers are reachable, all controllers have consistent versions, because just upgrading the vmanage, I think you have a plan to upgrade all your controllers. So before there, you just check whether all are in same version. All controllers are in sync. So this is the red box I have given. Just check, go there to the configuration controllers and check all controllers are in sync. This is one of the basic checks. So these checks, if you do, I think you will never fail upgrade. So now vmanage control connection validation, number of vbonds, vsmart matches setup, show control connection. You can see there are, why there are 8 entries, because in vmanage also we are running 8 vdaemons. So when we are running 8 vdaemons, these are the 8 entries. Just check the vbond count, vmanage count, vsmart count, and all these are intact post and pre-upgrade also. Service cluster check, service sales config db 1 or 3. This is something application server is not running, stats db is not running. Don't just simply decide to go for a cluster upgrade, because here you need to solve this first and then go for a upgrade. That's why I've captured this. Here there is some problem. On cluster node 3, application server is not running, statsdb is not running. For a 3 node cluster, statsdb should be there in all 3. Everything should be there in all 3. And application server, as you know, should be there in all the nodes, because Wildfly is deployed everywhere, because you start the operation for all the services via Wildfly. So this is a problematic state. You solve this state via analyzing the log and fix this, or open a tag case, and Cisco need to solve this before you decide for an upgrade. Message server across all node, connectivity between cluster IPs address and all. So cluster upgrade need to be done post these checks. Now, some of the deployment has disaster recovery. Validate the replication has been successful or not on the last replication cycle, because there may be something broken between the DCDR, which we never considered before the upgradation of the DC and DR, and we may land into some issue, or we may not be able to troubleshoot, thinking that okay, post we have upgraded the DC and DR, my replication is not taking place. It may happen that your replication was not going on since you were in older code, but as we have upgraded, we will be troubleshooting on those nodes, considering that we have a problem. So now disaster recovery failed. If disaster recovery is failed, if you have a DCDR, better troubleshoot it and get it solved now itself before we go for a upgrade. Because again, upgrade will give us upgrade may give us a idea that my upgrade has faulty DCDR operation. So if I have a DCDR, just check this and this before the upgrade. So I'll end the session here. Thanks for attending this, and I'll hand off the ball to Guru. Over to you, Guru. I'll stop sharing then.
Thank you, Anab. Guru will be back shortly. So thank you for this comprehensive and very detailed troubleshooting session for me, Vmanage. I hope everyone learned a lot, and we do need a lot of time to digest as well. I think based on the schedule, we will have a break for 15 minutes. Then we will be back in 15 minutes time. Thank you,
Okay.
guys.
Thank you. Thank you, guys.
All right, team. Thanks. Welcome back, everyone. We will start with Cloud On-Ramp, SaaS, and IaaS. Okay. Over to Ram. You are the presenter now.
Hey, thanks, Guru. Just a minute. I'll share my screen.
Yeah, sure.
Hey, Guru. Just give me 1 minute. I have to change my settings so to share the application.
Yeah, sure. Go ahead. Yeah.
I'll be back. Huh?
Yeah.
Hi, Guru. I'm back.
Yes. Yeah. We are able to see the slide. Yeah. Go ahead.
Yeah, sure. Let me start. Thanks.
Yeah.
Hey, hi, everyone. This is Ram. Yeah, so today we'll be covering, I'll be covering the Cloud On-Ramp, Cisco SD-WAN with Cloud On-Ramp for SaaS and IaaS, Infrastructure as a Service, these sessions. So to begin with, yeah, to begin with, so let's see what is the all the enterprise networks are moving towards the cloud, right? And today's traditional network has more or less they have the data centers in the physical data centers, and they are moving towards the cloud services like private clouds and public cloud services, where they do host their services workloads in the public cloud services like Amazon, Microsoft, Azure, and Google Cloud, right? So this is the they're moving towards the infrastructure as a service provided by the public cloud providers, right? And then for the cloud on-ramp for SaaS is used for service software as a service. For example, applications like Office 365, Google Suite, Dropbox, Salesforce, and there are many other applications. Okay, so these are the these are the shifts which is happening in the enterprise world, where they want to move all their applications and traffic from the physical data centers to the cloud, so that which saves them cost and also on the operational cost, and also it gives more TCO, right? So this would be the shift which is happening, and so we'll be focusing on these two. How do we integrate SaaS and IaaS with Cisco SD-WAN? Okay. So yeah, so basically, this is the same thing which we have seen. So in the traditional environment, we have their private data centers where they have all their workloads, firewalls, WAN network, all the services, load balancers, everything is in their traditional network. and how do the branches access. Everything was focused towards from the branch. The users would be accessing the data center. The traffic was always going towards, the focus was to connect to the data centers, because all the services were hosted in their data centers, in the private data centers. Right? Either they were using APJC tunnels or the MPLS or internet paths in the traditional environment. So they used to have VRF routing, per VRF NAT, APJC firewall, load balancing, NetFlow, QoS. These services were enabled for in their existing traditional networks. Now, when they want to move to the cloud, what are the benefits they're going to get? And some of the cloud providers are being shown here. So all their services, like your workloads and your database apps, everything is getting moved to the cloud environment. And how SD-WAN can achieve, like what are the benefits we are going to get is basically, one thing is like cloud connectivity, automation with Vmanage, and also you get micro-segmentation with similar to VPNs. You get micro-segmentations and also application policies to choose the best path, and more visibility. You get more visibility, and also with cloud you get the applications auto scaling. So scalings and stuff would be very quicker in terms of deployment. So they get all the advantages with cloud, and also integrating with Cisco SD-WAN. They get the security, they get their visibility, and more automation. Everything would be available with the Cisco SD-WAN integrated with the cloud networks, like private clouds and public clouds. So yeah, so this also represents a different way of same idea. So here, like everything is cloud, right? So here you have your private cloud. The WAN is integrating, you have your private clouds, which is your DCs or private networks, where your services are hosted, and the public cloud networks like Google, Azure, and AWS, and also you have your SaaS applications. And branch users or the campus users can access all of these from the Cisco SD-WAN, all of these via the WAN SD-WAN network, right? And some users who have their mobile devices can also access the same all three networks at the same time using securely through Cisco SD-WAN. And right. So what are the benefits you're going to get with Cisco SD-WAN cloud on-ramp, right? So here, first thing is insights, which is more insight in the sense of visibility, performance of your applications. So you get end-to-end performance from the branch to the cloud, since you have the application visibility and also the performance visibility end-to-end from the branch, because we will be running the latency loss between the branches to the cloud providers itself. So when this, even for your SaaS applications, you can we'll be running the latency and loss parameters, probing that, and based on the best path performing best, which path is performing better, you'll get the traffic moved on that. So you get to know about the path visibility, and also based on that we can take our basically the decisions might be taken based on the best performing path, and traffic would be moved on to that path selection basically, right? And also you get more secure segmentation with your end-to-end VPNs are segmented, and you get to access the like full stack security would be available on the edge till the cloud. Say when you have cloud on-ramp for IaaS, you get to have the VPNs defined in your branches as well as in the cloud, so that your your entire network is segmented and it is fully secure, right? And with automation, say for example, like when Vmanage is integrated with the cloud multi-cloud network, you get the automation for the cloud side as well, which you can from Vmanage, the APIs are called, and you will be able to configure the cloud side. Say for example, Microsoft Azure, side of configurations would also be pushed from the Vmanage, which automates the deployment smoothly and quickly. And one more thing is on the policy enforcement. So all the policies can be enforced from the Vmanage itself. So the automation and multi-domain policy enforcement happens only with a single pane of glass, which is the Vmanage. Right, and so Cisco actually brings up the strategic partnership with the public cloud providers like Microsoft Azure, AWS, and Google Cloud. So which would help in terms of like most like more direct peering. Directly, we do have like for example, we do have bring more in the, like how do I say that? We get the with say for example like Microsoft, we do have a better relationship, and with that we are able to get more informations like telemetry and stuff, which can help in selecting the paths even within the private cloud, sorry, public cloud, and choose the best paths and stuff, right? And for this SaaS again, we do have around 13 SaaS applications supported as of now, and for the cloud and sorry, for the co-locations and interconnect, we do have partnership with Megaports and Equinix and many others, right? And yeah, so let's focus on the cloud on-ramp for SaaS. Okay. Yeah. So this is how the traditional network accessing, in case of a traditional network, how do they access these SaaS applications, right? So usually a remote branch would access any internet applications via their data centers, because let's say, for example, the internet breakout is only available in the data center. This is a normal MPLS only network, an enterprise network with only MPLS. Even if they had internet, they usually have their firewall and security cluster, security zones. Everything would be in the data center or the hubs, right? So all the traffic would be like, say for example, the default route would be originated only from the hubs, and all the traffic would going towards the internet would hit the data center or the hub side, and then from there security zones, passing through the security zones, they would access the internet, and even for the SaaS applications. So what are the problems we do see here with this kind of network is like the traffic has to cross or backhaul over the MPLS network to the data center, which is a costlier transport, and and moreover we don't have any other path. This is the only path available. It is it is not predictable, and there's no optimal user experience, because this is the only path which can be used, or like no even if you have an internet link which can be used at the branch, which might be a better path, we do not use that. And also when it has to cross through the hubs and data centers, the latency will get obviously increased, because it hops onto another site, right? So even say because of this, you will have an increased application latency, or could have, right? And say with SD-WAN, of course, you get some of the advantages. Say for example, you have multiple exits. Say you could have a DAA path. You can force the applications, match the applications, and force it over the DAA path is one of the advantage which you get even with the SD-WAN. So you have multiple paths now, and you can reduce the latency, but it may not be optimal at all the times. So you say for example, this is DA path, and there's a, like in traditional case, the traffic goes via the hub or the data center, and then goes to the internet via the same security zones and stuff. That is one. And or regional hub or the data center, basically, right? Multiple options are available with the SD-WAN. So where you do a breakout, you can enable the zone-based firewalls and other security things, which if the device is supporting, you can enable that at the remote sites. right? So you don't have you have multiple paths, but we don't know is it the optimal performing path the traffic is preferred, right? It is more deterministic, but it is not optimal. So you can say the first preferred option is to use your DAA path, and maybe the second one is to use the regional colo, and the third option is to use your data center path. So you can set your preferences on the traffic flows and choose the paths, but it may not be optimal because of the latency and other loss and latency requirements based on the it may not be the best path, right? And so now and moreover customers might want to know their performance visibility on the performance, which path is performing better, right? So that is also available with Cisco SD-WAN on cloud on-ramp for SaaS basically. And they want to know like how is the security applied and where is the security applied in case of with cloud on-ramp for SaaS, right? And these are the basic constraints which would be asked by any database networks, right? And let's see how do we solve this using the Cisco SD-WAN for cloud on-ramp. Say for example, let's consider a scenario where you have a branch which has multiple DAA. For example, like we have Internet 1 and Internet 2, and now the remote side wants to access these SaaS applications, and how do we like what happens in case of this, right? So basically from we'll have to define the applications and which SaaS application we want to do. We have to add it to the branches. Once the defined applications, SaaS applications are defined on the branch, it will send the probes to all the SaaS application defined applications through the both Internet 1 and Internet 2 links, right? So once that is the probes are sent, we do calculate the loss and latency, and based on that we select the best performing path, and based on that the traffic would automatically be selected for the end host. The users would traffic coming from the users would be sent over the best performing path, and this is all and in case of a failure happens, then the traffic would automatically switch over to the other path as well. And say for example, this is like when you have this is another option. Say for example, when you have your only single internet link at the branch, and you have a hub site where your internet is available via the hub site as well, right? In this case, you have a local internet DA exit, and you have an MPLS transport, which is to reach your data center or the hubs, and from there you access your internet. So with this setup, again the probes are sent from the branch, one via the local DA site, and you'll have to select your gateway site. Once the gateway site is selected, a probe is sent from the probe is also sent from the gateway sites, and there will be a BFD running between the branch side and the hub side, right? So there will be a cumulative of this average would be taken, and the QoE score will be calculated based on that, right? Based on these two parameters, cumulative QoE score will be calculated for this path via the hub and all the data centers, and both it will be compared with the local DA exit and the hub. The QoE score will be calculated, and whichever link is performing or the path is performing better, the traffic would be preferred on that path. Again, this is fully automated. So the cloud on-ramp for SaaS workflow will be very. I will go into that later. I'll just go into that. Okay, so here is what happens on the underlying how this SaaS operations work, cloud on-ramp for SaaS operations work, right? Say for example, when the Vmanage router would Cisco Vmanage router would probe the send the probes to the DNS servers, and basically it would resolve. It can resolve via the ISP1 and ISP2. For example, we have two internet links, and the probes would detect for the SaaS applications and send to the DNS servers. And that would be it can resolve different IPs as well, and the probes can send it. Actual traffic can be probing can be sent to the SaaS applications on the ISP path, different ISP, based on the DNS resolution, the packets DHCP HTTP packet would be sent to the SaaS applications, and loss and latency would be calculated based on the HTTP probes. And whatever loss and latency is calculated, we do take a 6-bucket average of that, and the VQA score will be calculated. And say whichever score is better. So say for example, in this case, the ISP1 score is calculated and comes up to 10. That is the best performing path. And based on this, the traffic would be preferred, or like traffic would be selected on this path using the ISP1. Right. But these are the applications like Amazon AWS Box, Sunquare, Dropbox, and these are the applications like you see here. These are the supported SaaS applications currently. Right. Yeah. So so basically, how this is being done in case of detection for the DNS, like say for example, a probe is sent to Office 365, right? From the manager router, a probe is sent to the DNS servers. DNS server should be configured in your VPN 0, and for based on the DNS configurations at DNS servers, the probe or the request for that application Office 365 probe would be sent on both the internet links or all available internet links, and the based on the resolutions, a probe would be sent, and the latency and loss would be calculated. And we also should the requirement is to have your NAT enabled on both the egress interfaces, and that's when the traffic would be or the DNS query would be sent on both the paths, right? And we'll see what happens. This is from the router perspective, and what happens from the user traffic perspective, we will see in some time. Right? This is from the router perspective, initially how that direction happens and which path is selected. The probing is selected, which path will be selected for the probing, right? So that is what we see here. And so on each interface, the DNS query is sent, and based on the latency and loss for that destination IP, which it resolves, the QoS score is calculated, and VQoS score is an average which is selected. We'll go into that as well. Okay. Yeah, so this is optimization. Say, for example, like we did the QoS detection DNS. We saw the DNS query sent, and now how the probe is sent for the Office 365, right? So, like every SaaS application has their own probing, URLs, HTTP URLs defined, and the managed router would send the HTTP query to the particular SaaS applications. In this case, for example, Office 365, HTTP probe would be initiated from the managed device after the DNS resolution happens. A HTTP probe would be sent, and the latency and the loss would be calculated based on the IP which it is resolving. And the probe would be sent on all available internet paths, whichever has enabled with NAT. So how many probes and how do we calculate that, right? So in this case, you see one single like probe will be sent every 1 second, and then out of this you'll get of 30 seconds, like 1 second 10. You'll see this every 1 second a probe is sent, and it sees for again 20 seconds. Then this would be done. This will be repeatedly happening, and out of which you get one bucket for 2 minutes. Every 2 minutes you get one bucket, and this is an average which will be calculated, and then that is calculated for one bucket, and you calculate 6 buckets, and an average of this would be used for your VQoS score, right? And this is probe is basically provides you it's a table which will be plotted with loss and latency information, and that will be used for your the probes would be used for the VQA score. Yeah, right. So how the path is selected is basically we'll show you here is what happens, how the VQA score is exactly calculated. And so the probes are sent on both the paths, and it will be continuously being sent on both the paths, right? And when the loss and latency is being calculated, basically with the following formula, like desired loss and by the average loss into 100, and similarly desired latency by average latency into 100. So this value gives you a VQA score of loss and latency, and average of these two would be taken for your VQA score. And once the VQA score is calculated, it is defined with, say, for example, 0 to 10 is the score, and anything between 0 and 5 would be considered as bad, and 5 to 8 is average, and beyond 8 to 10 is like good. So and if both the paths are good, yeah, again in that case the traffic would be load balanced on both paths. Okay, and this is what happens for the user traffic. Right now, till here, what we saw is like from the router, how the QoS score is calculated, right? Now, what happens traffic from the user, how that is getting diverted to the best performing path, right? So here now you see a user mission is going to access Office 365, for example, right? He would initiate like Office mail or access like SharePoint or something, or accessing the Office 365, right? When the DNS query is sent to the destination, the DPI engine on the SD-WAN router would kick in, and it would intercept the DNS query, and then see that okay, it's a packet for the Microsoft application now, and intercepts that, and then it forwards based on the already it knows the best performing path, and now it would forward based on that path selection process, which was already done using the VQA score, right? It knows the best performing one. So now it based on the DPI engine, it sees that the packet DNS query comes from the user for Office 365 application, and it sees that, and it forwards the traffic to that best performing path. So the user gets the same DNS response similar to the Vmanage device, right? Once the packet is already comes back, the user would see that user traffic would and basically this is only for the DNS. So the DNS resolution happens to the host via the same path. So the response is very similar to the SAS probes was run initially, right? It will be the same or the similar one which is going to resolve for the end user also. And this would override the settings, which even if the user has a different DNS server settings, even though it has the host might have a different host settings configured, like similar to 8.8.8 or an internal DNS server, it would override, and the traffic would be sent to that particular DNS server, which the same was resolved on the router as well. And the traffic would be sent back to the or the DNS response would be sent back to the host, right? And for all non-cloud applications or non-SaaS applications which is not defined, those traffic would follow the DNS query, and will follow even though it hits the SD-WAN router and passes through it, it will be allowed to follow the routing table and forwarded based on the routing table information only. Okay, and how the application steering happens after the DNS resolution happens, right? So the initial traffic, say for example, a first flow is initiated from the user from the LAN, right? There won't be any cache or anything on the Vmanage devices. So till that cache entry is created for that application, the first flow, right? For the first flow, the traffic might prefer any path. It could be a non-performing path also. It doesn't matter. Like it can follow any path, and it can choose the available any one of the available path. And in case sometimes it could be a non-performing path also. The traffic would prefer a non-performing path, and the initial flow could have been on the second path. For instance, we'll take that it went via the non-performing path. So what happens from the second flow from a host B or from the same machine? When that happens, two different users or many users, like it could be from any flow. Once a DPI cache is created or generated on the Vmanage, once a cache is created, after the cache entry is created, the DPI would kick in and the traffic would be routed or basically would be routed based towards the best performing path or using the VQoS score. Any flows after that with the cache entry on the Vmanage device would be forwarded on the best performing path. So once this, but in this case, your even though the cache entry is created, your initial flow would not be disturbed. It will still stay on the existing path. If we because why? Because of the TCP sessions and the NAT would break if the session is like if you want to read out it. So that's the reason the traffic would not be the initial flow before the cache entry is created would not be changed. It would stay on the same path via which it was routed. It could be any path, maybe by chance, based on the source destination IPs and ports, it could have preferred the best performing path or non-performing path as well. Right, and yeah, so what happens in case of the like one in case of a how the discovery happens in case of your local branch. A branch router has a local internet DAA path, and also it has a gateway site. Right? So DNS server should be configured on both your remote site as well as your gateway site, and NAT should be enabled on these interfaces as well. Right? Once this is done, so basically a probe would be sent from both the routers from the remote Vmanage. It would send using its local DAA interface, and a probe would be sent from the gateway site as well. Right? When this happens, a branch might have a can have a DNS resolution happens for this cloud, like Office 365 URL probing URL, the HTTP URL which the manager to probes can resolve to two different IPs at the branch and the gateway site. It could have resolved different IPs. But still, the probe would be sent on from both the branch and the gateway site. Right? And and now once the resolution happens, now the probes will be sent independently from both the routers, from the branch as well as the gateway side. And now the QoS score would be VQoS score would be calculated. How that is happening is basically say for example, to Office 365 probe is sent to the Office 365 URL. It might get, say for example, if it is getting let's say it gets a latency and loss of like 100 milliseconds and a loss of 2%. But the gateway side is getting only no loss and then latency is like 50 milliseconds, right? We get this QoS, we calculate that loss and latency on this path and from the branch as well. Now, a cumulative score of this path, say a BFD is running between this like over the SD-WAN IPsec tunnels or the SD-WAN fabric, branch to gateway side will have BFD tunnels running, right? So now using this BFD as well as the cumulative score which will be calculated on the internet link at the gateway, we do add these two, or these two will be added, and the cumulative score will be calculated, VQoS score will be calculated via the gateway. And these two would be compared and via the branch direct internet and via the gateway, cumulative score will be compared, and whichever is best performing path, the traffic will be preferred on that path, or diverted via that path. Okay. And okay, one more minute. Yeah, so I forgot to tell you this. So how this cumulative score will be calculated, and from the branch it has to know, right? So basically this whatever gateway site performs the probing, right? When the QoS score is calculated from the gateway, that info would be propagated to the branch via the OMP. And that info is published, or like will be published to this info via the vSmart using OMP, and that's how the branch would know about this the entire path information. Right? And then now how the traffic would flow on the via this let's say in this example, the traffic flowing through the best performing path, which is in this case is the via the gateway site, right? Now similar case, when a user sends his probe, or like accesses the application, DNS query is sent to the Vmanage router in the branch, and that would being intercepted on the Vmanage router. DNS query would be intercepted, and the traffic, the DNS query would be routed, instead of using the DAA path, the traffic would be, DNS query would be routed to the best performing path via the gateway. Right? Once that is being sent to the gateway, the traffic would be sent through the DAA path at the gateway site, and the DNS query would be responded, and the response would be collected and sent back to the host. Similar to from the branch, similarly, the non SaaS applications would be routed to their to the destination. DNS destinations would be sent to their respective DNS. It would not be intercepted, and it would be routed based on the routing table, or forwarded to the DNS servers exactly, which is configured on the user machine. And yeah, so this would be the traffic, how the traffic flow happens, similar to the branch, how the traffic is routed on the or from the host, how the traffic will be routed on best performing paths. So in this case, again, similarly, after the DNS resolution happens, the traffic sent to the actual cloud on-ramp application, SaaS application, the initial traffic might choose any path irrespective of the best performing path, right? So in this case, the traffic would be like your preference would use your local DAA. I could have used your policy, or a default route would be pointing to the local DAA. It would follow the routing, and the traffic could have been sent via the local DAA exit. And once the cache is DPA cache is created, and now the cache entry is created on the routing, on the Vmanage router. Now from the second flow, from the same user or from a different user, cache to DPA caches entries created, the traffic would be diverted to the best performing path based on the SaaS VQoS score. Right? And the initial flow will not be disturbed. It will still be running on the same path, just to avoid the breakage. The traffic would break if we change the path, right? So we wouldn't change anything on the existing flow, the initial flow which was sent before the DPA cache entry was created. Okay, now so we will see how Cloud on-ramp for SaaS can be configured. We'll be seeing that. So basically, to enable SaaS, this is a very simple 3-step process. So you'll have to select the applications and VPNs. So SaaS applications should be selected. Say, for example, we have 13 applications in the workflow. So you can select all or any applications which from the list you want to choose, and the VPNs, from which VPNs you want to use this SaaS Cloud on-ramp for SaaS. Right? And also once you select the applications and VPNs, then we have to select which DAA sites we want to configure the cloud on-ramp for SaaS. Once that is done, we can also select the gateway sites, which is an optional one, but yes, you can do that as well. Or cloud gateway sites are optional ones. But in most cases, it would be a scenario, yes. We would need to have the gateway sites as well, like to have the regional backup site or best performing path to select. Right. So in Vmanage, so the first thing you'll have to do is like on the Vmanage settings page, you'll have to enable Cloud Express. So Cloud on-ramp for SaaS you'll see a name for Cloud on-ramp for SaaS in the settings page. Once you click on edit, you'll be seeing Cloud Express. Basically, Cloud Express was the previous name for Cloud on-ramp for SaaS. That's the reason you see Cloud Express here. Yeah, so and you have to select enable and save. Once this is done, that is when your workflow for Cloud on-ramp for SaaS would come up even. Till before that, you will not be even be able to enter inside the Cloud on-ramp for SaaS workflow. If you go to that workflow, it will tell you to enable that in the Vmanage settings page. So here we'll have to so basically what we'll have to do is like select the applications and policy. So here you can select the applications. Basically, when you click on the enable or disable, there will be a drop down. You can select this enable or disable option for the applications and the VPNs. You can select based on this the applications and then save the policy, save these applications. Once this is done, yeah, sorry for the image actually. Yeah, so basically once this is done, you'll have to select the DA sites. Yeah, this is also wrong. So basically you have to select the DA sites. So here you will see whichever sites are enabled with the DA NAT is enabled. You will see all those sites coming up here, and you'll have to select move it on to the right side. Once that is done, you can add the interfaces here. You'll have which interfaces you want to select for the traffic. So maybe for example, you have dual internets at the branches. You can select any one or both. Right? For that options, you have whichever interface you want to select. I will see that as well. So once the site is selected, you will see that when you do next, you will see you can select the site, and on that you will be getting an option to select which interface you want to use for your the probes to be sent. So you can send it on one path or all the paths available. So if you don't select anything, then obviously it will be sent via all the paths. If you select specifically, then the probes will be sent only on that path, on that interface. Once that is selected, you can save and save the changes and move on. And now you can also select the gateway sites here. So this is all under the Cloud on-ramp workflow. On the top right, you'll have to select these options. Once you select the gateway site, again in the gateway site, you can select the WAN interface or the DA interfaces similar to the branch. You can select that and then save apply changes to the gateway Vmanage. So once your applications and your internet interfaces are selected, you will see on the dashboard, Cloud on-ramp for SaaS dashboard, you will see these are the applications we do support, right? So you'll see how many branches have been selected for these applications, and we will see the scores, VQA scores, and what is the status of them, and how many devices you have active on these policies are active on how many devices. Say for example, in this case, you have 11 devices active on these SaaS applications are enabled on 11 of the devices, and the VQA score for each application is being displayed here. Okay. So this, as we saw earlier, 0 to 5 would be bad, and 5 to 8 would be good. Average, and 8 to 10 would be good. It's actually wrong. Yeah. Based on that, you'll be seeing the QA score here. Okay. Now let's move on with the Cloud on-ramp for SaaS. IaaS, Infrastructure as a Service. So let's move on with that. So in traditional networks, what we do here is basically Remote branches would access the public cloud networks where the services or the workloads are hosted. Usually what happens is like since the connectivity to the cloud, public clouds would happen mostly via the direct cloud and the express route connections, direct connect and the express route. These terminations are like private links or private peering, which happens to the data centers or the colos and stuff. Right. So from here, we do enable IPsec tunnels to the public cloud networks. So with this, this is not a direct path. We get access to the mm, cloud networks, public cloud networks. So then also we lose the segmentation because of one single path. We'll have one IPsec tunnels running between the data center and the public clouds. So we do lose the segmentation visibility and also the QoS on the path. Depending on the underlying technology, of course, yes. Right. And now why do we need to, let's see, why do we need to extend SD-WAN to the cloud, right? Public clouds. So SD-WAN would give you advantage with like full SD-WAN capabilities would be there. Like you can select the path. It could be either internet or the express cloud path via the data centers, and and also via, say, for example, any other providers like Megaport or um, the interconnects, cloud interconnects, I would say. Choose the path which you want to use. That's one reason. You get more visibility, end-to-end visibility will be available. And automation is one thing, and single policy, a common policy framework would be used across SD-WAN and the cloud networks. And also you can manage your WAN routers within the cloud environment, like would be managed from the Vmanage configurations, and visibility onto that routers and stuff would also be within the Vmanage. And also you get the security, like security and segmentations would be available via the SD-WAN. End-to-end segmentation would be available from the SD-WAN routers in the cloud as well. Right. So this multi-cloud with cloud on-ramp is this is how the your deployment happens nowadays with the latest releases like 17.5. You'll have even 17.4. From 17.4, you get the cloud on-ramp for, instead of IaaS, we can use cloud on-ramp for multi-cloud. So single workflow which can be used to connect to any of these public clouds like Amazon, Azure, and Global Cloud, right? So basically, from the Vmanage, single workflow can be used to connect with or deploy the SD-WAN routers and configure the Azure, AWS, and Google Cloud. Let me see. Yeah, so basically what do we get here is so it is of course cloud on-ramp for the IaaS is transport agnostic. You can use internet or express routes or the direct connect paths, which private path which can be used, and end-to-end visibility. You get better application experience based on the path selection, the probes and the path selections. And you can have your consistent security policy on the cloud as well. Similar to your branch sites, you can have your same policies applied to your branch and the cloud, right? And also, if there is any different regions you are adding up on your cloud, you can scale horizontally. And from your Vmanage, your workflow, single workflow, you can automate the entire deployment of your cloud networks from the Vmanage itself. Right. And yeah, that's the and also one more thing is like it's a better solution from the Vmanage, because you get one workflow which you can get that deployed on the Amazon, like AWS or the Azure, workflows within their like if you want to deploy your routers from the Microsoft or Azure workflow, which would be more complicated within the environment. But if you use Vmanage, it's a few clicks away, and you can get it deployed from the Vmanage itself, which would be very simpler than the solutions which are provided from the service providers itself. Okay, so this is the three underlay options which can be used for the connectivity to the cloud. Say, for example, a branch router has to can have an IPsec tunnel via the internet path directly to the VPCs or the VNets or the other cloud providers, basically. So you can do a side-to-side VPN over the internet directly to the cloud providers. Right, and basically this could be the end host, actually host VPCs or host VNets. Side-to-side VPNs would happen, and there's other option is to have via the DC. So basically, a branch network would talk to the hub or the colos. From there, we have your direct connect or your express route connectivity to the cloud. And this would be the third option, is to either have MPLS and MPLS or internet path from the branch. You can go to the co-location facility via the SD-WAN tunnels will be established from here, and then you can have your traffic to the host VPCs or to the cloud providers, basically. This is via the co-location option, right? And yeah. Let's see, what do we have? Yeah, so now in the cloud routers, how do we have your cloud SD-WAN routers available? So basically what we do here is like Cisco would publish the software Vmanage routers, like say, for example, two options available for now, CSR 1000V and CSR 8K 8000V. C8000V virtual routers are available in the Azure and Amazon AWS. So they are posted. Those files will be available. You can use them to basically those are bring your own license options are available. And once you're deploying it, you can deploy it manually, or you can use the Vmanage workflow to deploy that. So we will have to we can use them from the those are available in the marketplace. Sorry. 1 minute. Yeah, and we will have to have their serial numbers from your in your virtual accounts. You'll have to have their serial numbers deployed, and those has to be attached to your Vmanage, and you can deploy it similar to an virtual router. You can deploy that in the cloud as well. And so you can deploy either one Vmanage router per VPC VNet, or you can also have redundant routers as well. But like it depends on your solution, on your particular design. Basically, you can have one or two, depends on your feasibility and stuff, basically. And for redundancy is managed from the either you can have redundancy with the routers also, and the redundancy is managed by the cloud providers also. Both options are available. And once your SD-WAN cloud SD-WAN routers are deployed, they will be able to form or join the fabric similar to a normal SD-WAN branch router. It would be able to reach the controllers with all the transports available. Based on that, you can have your like control connections and the BFD sessions. It would be very similar to a normal branch, but only thing is it's a cloud router in the cloud environment. Right? Once that is established, control connections and the BFD tunnels are established, you will be able to have multi-pathing, visibility, segmentation, QoS. All of these SD-WAN capabilities will be available on the from the cloud to the branch networks as well, physical networks. Right. Okay, then yeah. So what happens, or like how do we deploy? So this is actually the transit VPC option here. There are a couple of options available. We'll discuss that in some time. But yeah. Okay, let me be a little quicker. Okay, so in this case, you see here, we do have internet and MPLS via direct connect. You have both the transport in the cloud. Now Vmanage will be able to talk to the cloud provider in say via the API calls. It would be able to make the API calls to the AWS environment. But yeah, of course, you'll have to key in the credentials and the the AWS transaction keys and stuff. Basically, you'll have to key in them. Once that is able to establish the connection with the AWS, it will be able to, via the workflow, it will be able to push the managed routers and deploy the transit VPCs. So once the transit VPC is deployed and you select the transit VPCs, we will be able to deploy the managed cloud routers in the Azure environment within the transit VPC. And this would be the availability zone 1 and 2. It could be within the, we can select them as well, the availability zones within the AWS environment. Once the managed routers are deployed, it would be able to form IPsec, control connections with the controllers, and you will be able to manage these routers from your Vmanage, similar to a normal branch. And on the service side, what happens is basically you'll have to attach a template to these devices before doing any configurations. Yeah, so the template should be as a mandatory thing which you have to attach them. Once a template is attached, so on the service side, basically what happens is like you don't have a normal physical interface like we do have on the service side. We have interfaces, right? For this, in case of this setup, you may not have a physical interface here. What happens is basically a physical interface in the sense any interface attached to it. And instead of that, we will have IPsec tunnels running from the managed router to the VPN gateways of the host VPCs. Right. So IPsec tunnels would be established from the routers to the host VPCs here, and BGP will be enabled on those IPsec tunnels. So from each router, you will have two IPsec tunnels running for redundancy, and BGP would also be enabled on that. So basically, over these IPsec tunnels, we would be able to get all your host VPC routes to the managed routers. And that would be similar to normal service side BGP. You will get all these routes on the service side of our SD-WAN routers here, cloud routers, and those routes would be redistributed from BGP to OMP and similarly OMP to BGP based on the policies which you usually do in a normal SD-WAN environment. We will be able to redistribute them as well. Right? Once that is done, this paths would be obviously like similar to a branch router, normal branch SD-WAN branch routers. You can have your BFDs established to your DC hub sites as well as to your branch sites based on your transport availability at the remote sites. Okay. Yeah. So also like you can advertise default route, originate default route, and advertise it to the host VPCs as well. Like those are normal service side routing, which you can do it as well. So why do we suggest to advertise default route is basically there are limitations on the host VPCs on the routing table with these setups. So we might have to advertise default routes into the host VPC because this is a host environment. You can advertise default route instead of redistributing the entire OMP routing table into the service side. If the routing table is less, no issues. You can advertise the entire routing table, or else you can advertise only the default route also. Should be fine. Similar to AWS, we have the Azure setup where we have your internet and your express route gateway path. And Vmanage, once your Vmanage is able to, once we key in the credentials and the other parameters required for the connectivity, the API calls and stuff to the Azure environment in the workflow, Vmanage would be able to connect to the Azure environment and will be able to deploy your Vmanage routers, cloud Vmanage routers in the Azure Transit VNet gateway basically. So this will be the gateway VNet. Here you can be able to deploy your cloud routers here. Similar to that, in Azure, you can run IPsec tunnels and run BGP on the service side. And there's one more option is basically in Azure, since we do not need these IPsec tunnels in case with AWS, it's a mandatory. You will have to run IPsec tunnels with BGP. Azure also do supports that, but in case you want to push the traffic instead of using this, you want to route it to a firewall like Azure firewall or load balancers, you can still do that as well. So in that case, you might have to run static routing on the service side. So that's the difference which might be there. If you use if you want to route it via a load balancer or a Azure firewall in that case. So that would all be static routing on your service side, and basically on the Azure environment, it will all be UDS there. Okay, logically, it's exactly the same. Like Azure and AWS would be very similar from the SD-WAN perspective on the workflow. Right? With what are the like with the segmentation? How the segmentation happens with the transit gateway, how the transit VPC, right? So basically, the cloud providers initially, the public cloud providers like Azure and the AWS didn't have their did not support the segmentation within their environment. So what we had to do is basically the SD-WAN would have your segmentation enabled, and the IPsec tunnels on the service side from the SD-WAN routers, right? We keep them in one VPN, and every VPN will have IPsec tunnels running to the host VPCs. So now, whichever VPN you want, say for example, you have HR resources is in one VPN, finance resources in another VPN. So basically, you keep all these HR resources in one VPN itself, and terminate these IPsec tunnels from each VPN. You enable IPsec tunnels to these and have BGP enabled between them. So that way you have your segmentation enabled on your cloud environment also, right? But right now, the cloud providers have started supporting from 24 onwards or during some time back, they started supporting the segmentation, but it's not with this transit VPC solution, but they do have support from using the TGW and the Azure vWAN solutions. So that is also supported. And in case with this traditional setup, the transit VPC and transit gateway setups, this segmentation can happen from the SD-WAN routers at the branch. You can have your VPN 1 for HR, finance, and VPN 2 from the branches. We'll be able to talk only to the finance resources from these branches in VPN 2 because the host services, the host VPC or the host VNet, right, will host only finance resources in this VPN, and they will all be outed only in VPN 2 in the cloud routers, SD-WAN routers in the cloud. Okay. Yeah, so here we do see how the application-aware routing works. Similar to normal branch between the branches, SD-WAN branches, you can still have your application-aware routing enabled because the end-to-end application or path selection can happen based on your application since your traffic is going to be routed via the cloud routers. So yeah, BFDs and your app route statistics, everything would be run very similarly to a normal branches and the cloud routers between the branches and the cloud routers as well via the internet path as well as the direct connect path. So now from the branch, it can select the best performing path, or your application level routing can select the path based on your policies which we have compared. Right? And also can be used as a resiliency or like redundancy, and you will have both the paths available in case of with the Cisco SD-WAN, and end-to-end application level routing can be enabled. Guru?
Yes, Ram.
Guru, do we have time? How much time?
Yeah, maybe we can go for another 5 minutes. Then Vivek will start with troubleshooting. Yeah.
Okay. Actually, then, actually, I just want to show the workflows. I think let me show them. Actually, give me a minute,
Yeah, sure. Yeah.
or I'll just cover the yeah. Fine. Let me do it quickly. So how can we connect the interconnect with the cloud providers, right? So the basically we can have multiple options, right? So basically, normally in traditional environment, you have your branch running IPsec tunnels, side-to-side IPsec tunnels to your cloud VPN, like host VPCs. You can run your side-to-side VPN to your cloud providers directly. This is one of the option, and this is not an SD-WAN option, right? It's a basically a normal branch talking to your cloud providers side-to-side VPN. Okay? I'll just skip this part. So with SD-WAN, how do you get you what are the benefits you get and how can you do this, right? So basically, you can deploy your SD-WAN routers in your branch as well as your cloud in your cloud regions. You deploy your SD-WAN cloud routers. So the one which we saw, how do we deploy it and stuff basically. So once you do that, you get all your visibility, path selection, those stuffs. You will get that. So this is you deploy your um, cloud routers, cloud SD-WAN routers in the VNet itself, and you can establish IPsec tunnels directly into your host, into their VPC or the VNet environments, right? And the cloud routers are all based on your bring your own license deployment models, right? Yeah, so that is not a scalable option. So this would not be a scalable option because you will have to deploy every host environment or your region. You might have to deploy your own one or two dual redundant routers across every region and every VNets basically. Right here with transit VPC is one which gives you a more scalable option. Say you deploy one or two routers in your Azure Gateway VNet, and based on that you have your IPsec tunnels or your like basically you can from the transit VNet you can connect to all the host VNets within the region. So that way you get a scalable options. These are VPN gateways which are available within every host VNets. So you can able to connect to these host units in the Azure environment with the single or two dual routers deployed in your gateway VNet. So this way, this is the one we were explaining previously, and this is one of the option transit using the transit VNet option. And I'll just move on. So this one is the cloud connectivity with vWAN solution or TGW, right? So basically, how do you do that? Is basically from your branch, you can so the same connectivity is internet and express route remains the same. Transit VNet is also the same, but only thing is from the transit VNet, instead of connecting directly or establishing on the service side, you are not going to establish IPsec tunnels to the host VPCs. Instead, you would establish IPsec tunnels to your VPN gateway, which is in the hub VNet. So this is actually a hub VNet in the sense it's part of the vWAN solution within the Azure environment. So so now you're forming tunnels with the hub, and the hub would establish IPsec tunnels or VNet peering between the host VNet and the vWAN hub. So this way it's more scalable, and this vWAN hub can expand or multiple vWAN hubs can be available in different regions, and they can establish communication across the regions as well. This is one of the other option, and the other option is to directly deploy our SD-WAN routers in the virtual WAN itself. And this solution was supported from 24 and like 17.4 basically. So basically the SD-WAN routers can be deployed within the vWAN itself, and it's vWAN router or a virtual router within the vWAN environment itself. Now, so basically instead of transit VNet, you can deploy your SD-WAN routers within the vWAN hub solution itself. and there's no IPsec tunnels or anything you might have to do. So it's basically this router would pair with the V1 hub router directly with or a BGP, normal BGP, and it would have a normal routing with, let's say you have two virtual routers. One is virtual WAN router in the Azure environment, and this is Cisco SD-WAN router. So SD-WAN router would form IPsec tunnels and the BFDs and control connections, everything would to the remote branches, physical network. And on the service side, it would pair with the virtual router, virtual hub router in the V1 solution. And V1 hub router would do the routing with or the peers VNet peering into the Azure environment with other host VNets and other like express route connectivity and the express route gateway. All those connectivity would be done from the V1 hub routers. And you do not need an IPsec tunnel between the SD-WAN router and the V1 hub router. So that way your throughput and stuff would not be a challenge on the service side. Okay, so yeah, so that's a different deployment. So it shows you a different way here. So basically what happens is, like in this case, your instead of transit VNet, your SD-WAN routers are deployed within the V1 hub itself. And now this SD-WAN router would pair with the V1 hub routers, and the V1 hub would have the VNet connections to all the host VPCs. So like only difference is like you deploy the SD-WAN routers instead of transit VNets, you will be deploying it inside the V1 hub itself. That's the only difference. And this way you avoid the IPsec tunnels running. This is very similar to in Azure AWS environment, it is TGW. So in TGW, you will be deploying the SD-WAN routers directly. So that way you don't have to have IPsec tunnels on the service side as well. And everything remains the same. QoS, app hour policies, everything would be same. So these router deployments are even simpler with the multi-cloud workflow for deploying the SD-WAN routers within the V1 hub and the transit gateways. Okay, yeah, so this is what happens. Like say you deploy the workflow from the SD-WAN routers, the Vmanage would do a REST API calls to the Azure portal and deploy the SD-WAN routers within the V1 hub. So SD-WAN routers would be deployed, and you'll have to attach a template. And in the SD-WAN environment, in the Azure environment, the SD-WAN routers, the template would be pushed to these routers, and it would be able to establish control connections, the BFD service side. All of these things would happen normally similar to other routers. So now the entire router deployment and everything happens on the Azure environment with the multi-cloud workflow. Your BGP peering would be established on the service side with the V1 hub, and your BFD tunnels would be established within your branches and the SD-WAN routers here. And you can enable BGP to OMP redistribution and other stuff very similar to any branch routers. And this is supported from 17.4 and 24 releases. I'm done. Thank you.
Yeah, thanks, Ram.
Thank you. Thanks.
Yeah, maybe we can start with troubleshooting. On-ramp. Maybe I'll pass on the ball to Vik.
Yeah, thanks, Guru. Let me share my screen.
Sure. Vik, you have 30 minutes, okay? Yeah.
Okay.
Sure.
Yeah, sorry, Guru. I'm not able to share my screen. Let me just give the slide to Nitesh, and Nitesh will share, and I'll give the presentation.
Sure. Okay. Nitish, you are the presenter now. Go ahead. Yeah. Nitish, are you able to hear us?
Yes, sorry, I was on mute. Yeah, I can hear. I'm just waiting for the Vivek to send me the presentation.
Yeah, Nitish, I've already sent you. Please check.
Yeah, I'm just opening up.
Yeah, go ahead, Nitish. It's visible now. Yeah.
Yeah, okay, thanks. Nitish, please make it full screen if possible. Yeah, thank you. Yeah, hey, hi guys. Hello everyone. Hope you guys are doing good and staying safe. So welcome to the session on the Cloud On-Ramp SaaS troubleshooting. My name is Vivek and I am part of SD-WAN tag team since last 3 years. Please go to the agenda side. Yeah. So in previous session, we covered a lot about the Cloud On-Ramp. So in this session, the agenda of the session is the first we will discuss about the SaaS adoption and the challenges. Then we will see how SaaS work on the back end, VQoE calculation, monitoring of COR and Vmanage, and last two topics, COR, SaaS troubleshooting, and COR IAS lab walkthrough will be covered by my colleague Nitish. Yeah, please next slide, Nitish. So as you can see that SaaS has been increasingly getting popular day by day. So there is no doubt about it adoption. Most of our customer in today's scenarios are happily enjoying Cisco SD-WAN Cloud On-Ramp, and for other deployment is on pace. But when we talk about the challenges, customer also have a question in mind about the security and performance, as the SaaS looks so fancy without proper understanding. So for instance, if I put, if we are talking about the challenges, let let things let think that if I put all my appliances in my in on-premises, then I know everything is secure and performance is also good. But we generally don't trust something when something in the cloud. So question is, how do we ensure customer applications are secure with better performance? So in the same way, likewise, the same thing is happening with the performance also. In on-premises, network performance is quite enhanced, and what we have to go all through the cloud to access the application. Customer has questioned that performance might be degraded if the SaaS application is somewhere in the cloud. So beauty of the Cloud On-Ramp is that it is designed in such a way that it will overcome these key challenges, security and performance, and we will see this in the further session. Nitish, please. Yeah, thank you. Now the customer are typically accessing the SaaS today in these design. So first, one could be a no DIA at all. In this use case, branch is connected to the data center, and our cloud on ramp application can be accessed via data center only. Since since branch is not having DIA link, so it has to send all the cloud on ramp traffic to the data center, and from the data center it will take it further. Another is the second is single DIA. So the single ISP is there on the branch side. So here branch has one internet link to go to given SaaS application, where the branch itself can break out to the internet and reach the SaaS application. Now our third example is that most of the customer is having this dual functionality, dual DIA on the branch. Here the branch is having options. Here branch is having two ISP connection to reach out to the SaaS application. One link is act as a primary and another one is a secondary. So which one is the better link? The traffic will go to that link based on the VQA score that we will discuss in next slides. Yeah. So DNS resolution, performance visibility, and path selection. So these are the 3 steps for the cloud on-ramp for SaaS to work. So basically what happens when you configure cloud on-ramp for SaaS on a branch router, the branch router proactively send probes the SaaS services. So first it send the DNS request and get response. Once it get the DNS response, then it start HTTP ping, basically probing the SaaS service to ensure whether it is available or not. In case if it is available, then what is the loss and latency, and based on that it define the path. Then the third step is our path selection. So the path selection will be on the basis of the VQA performance score. So performance visibility for dual DIA. So when you configure cloud on ramp, let's take an example of Office 365, one of the application out of the available application stack. So cloud on ramp for SaaS will be enable the router to send DNS request for Office 365. As you can see in the first point, DNS request pre-configured DNS request has been DNS has been pre-configured on the VH or CS device. Now in step 2, DNS request will replicate on both the ISP link. So whatever the ISP link it is having on which DIA has been pre-enabled, so it replicates the DNS request on those links. So regarding the DNS under VPN 0, we always recommend to configure a common DNS such as 8888. So you will get so if we configure the common DNS, so it will help to get the ISP DNS response, ISP independent DNS response, and 8888 will provide you most optimal front door of a SaaS application in return. Now in step 3, once DNS response is received, so whatever the DNS request we have sent to O365, once we get the response for that DNS request, now after that it will use that response and start sending HTTP ping on backend. Those HTTP ping will be monitored to understand how the link is performing, and this HTTP ping will help us to get the probe, and these HTTP probes will help us to get the latency and loss of that link. Yeah. So this is something that is important to understand for cloud on ramp troubleshooting perspective. So here in first line, if we take 12 minutes moving average to avoid flip-flop of the path for the application flows. So within 12 minutes, we have 6 buckets of 2 minutes. As you can see, 0 to 12. So we have 6 buckets of 2 minutes each. So if you multiply 6 multiply by 2, you will get the 12. So going further, those 2 minutes, now we are talking about the only single bucket. So those 2 minutes are further subdivided into 4 sub buckets of 30 seconds each. So first, there are 6 buckets of 2 minutes each. When we take the example of one single bucket, that single bucket is subdivided into 4 sub buckets of 30 seconds. Now in each 30 seconds, what will happen? It will send the 10 HTTP ping to the SaaS application. Suppose any of the SaaS application like the Dropbox or 365, and get the response to. So for 10 seconds, it will send the HTTP probes and get the response. And for next 20 seconds, it will go silent. So that covers our whole 30 second. 10 plus 20. For 10 seconds, it will send the HTTP packet. For 20 seconds, it will go silent. Then we repeat this process for another 3 times. That makes 2 minutes, or we can say 1 bucket. In the same way, we take an average of all the 6 buckets. So in 2-minute window, we calculate the performance characteristics, and then we keep the account of 6 window of 2 minutes each. In this way, we calculate moving average, and that help us to calculate VQA score for the paths. So, so in this way, we can calculate the VQA score of the link. So VQA. So first of all, VQA stands for the Viptela quality of experience. It is in the range of 0 to 10, where 0 being the worst and 10 being the best. So if the application scores between 8 to 10, then it is considered to be very good. If it ranges between 5 to 8, then it is okay. And but user will tolerate. But the third one is if it ranges between 0 to 5, as you can see with the red block, then it is a problem, or we can say that it is a worst link. It is a worst link, and there should be some other link that is having the high VQA score. Here in the slide, you can see the word baseline loss and baseline latency in the formula of VQA loss and latency. So what does it is? It is actually loss or latency provided by a cloud monitoring services. So these loss and latency is calculated by there are some cloud monitoring services. Those services calculate these baseline loss and baseline latency. Yeah. So DNS resolution for the end user packet flow. So so when users send the DNS query, so suppose our US users in the A section, you can see the when user send the DNS query, the user may be configured with enterprise DA. So it is not needed that the whatever the DNS configured on our VH or CS device, the same DNS should be configured on the user end also. It is not not required. So it may be possible that the user may be configured with with enterprise DNS. So the DNS query comes to in B section, if you can see that. So the DNS query comes to our VH and CH router, and router takes that host DNS query. So first of all, it checks the DNS query, and and now it checks check with the DPI whether it is for the SaaS query or some other application. If it is for some other application, then it will check the routing table and behave accordingly. But if it matches to the SaaS application, if the packet belongs to the SaaS application that is configured, then it hijacks that packet. Then it hijacks that packet and it replaces the DNS server to the one that we have configured on the router, on our VH or CH router for the SaaS operation. Now in step 3, now the request is sent over the best performing ISP link on the basis of our VQA score that we have just explained. Best perform yes. So on the basis of whichever the link is best, whether it is ISP1 or ISP2, it will send the traffic to those that link. So what happens when the response comes back? The router again takes the packet and replace the DNS server with the host configured DNS entry, and also reduce the TTL to avoid caching. So this is the whole process. So in this whole process, the end user doesn't aware about what happening in between the transition of the flow. But what is the best for for his perspective, that the user traffic is getting the best possible path. Yeah, please next slide. Thank you. So here we see that what happened to the first packet of the SaaS application flow. So like, so the first application flow, when it enters the router after DNS resolution, the router DPI engine is, so for the first packet, the router DPI engine is not aware about it because DPI engine is not bind to identify the application. So the packet may end up on the sub-optimized link. So it could go either way. It could go to the, it may go to the either ISP1 or ISP2. So based on the characteristic at that time, so it will not choose the optimized path. Yeah, second slide. So as we can see that the first packet of the SaaS application, it may go to any link because DPI is not bind to the identify application. But for the subsequent flow, for the second and another packets, when those packets comes in, the DPI engine will check the packet with the intelligence. It understands that it is for the SaaS flow and put it on the best link that is optimized. So now our REST packets are behaving as expected. That now it is following following the path on the basis of VQoE. Yeah. Now we come to the monitoring section. So once you configure the cloud on-ramp, so the configuration part was covered in the previous session. So once you configure the cloud on-ramp, you need to know whether it is working or not. So that's where the monitoring comes into the picture. So as you can see in the picture, there are 3 applications that is configured out of the out of the whole application stake. So here in the cloud on-ramp for SaaS dashboard, you will see all the application that has been enabled for the cloud on-ramp. So here you can see the first thing you can see that how many cloud on-ramp application has been enabled. So we can see here that that only 3 application has been enabled for this Vmanage. The first one is Dropbox, Office 365, and Google Apps. Now, second thing that we can observe is that how many sites are using that particular application. Suppose we are having 50 devices, but here only 3 active sites are are enabled for the cloud on ramp. So only three branches or 3 sites are using these services. Third thing that we can see here, that VQoE score of those sites with respect to the application. Now here we can see that there are 3 three quality parameters: bad quality, average quality, and good quality. For the Dropbox, we can see that we are having 4 devices here. So we can see that all the 4 devices are having good quality for the Dropbox. For Office 365, we can see all 4 devices are also having the good quality. But for the Google app, we can see that the 3 is showing as the average quality. When we are saying the average quality, good quality, and bad quality, we are talking about the VQoE score. So average quality means that the VQoE score is somewhere lie between the 5 to 8, and the good quality score is between 8 to 10. So in the monitoring section, if you if you click on any one of the application, then it will show you the details of the sites. So also, if you click on any of the particular site, then it will show you the historical graph showing that particular how particular application has behaved. So you can get the graph for the like 6 hours, 1 day, 7 days, or you can just customize it as per your requirement. That's all from my end. Now Nitish will take over from here. Nitish, over to you. Thank you.
Thank you, Vivek. Hello, everyone. This is Nitish here. I'm the part of the SDWAN Tech from the last 2.5 years. Almost everything has been covered from the theory point of perspective. Vivek has covered almost all the thing, and also the previous slide, the previous section, the Rama has covered. Almost everything has been covered. Now I will take you through some troubleshooting commands on the VH, what to look at, how we can configure, how the configuration looks like on the VH, and all what are the SOAP commands, what are the debug command that we can run. So yeah. So CR SAS troubleshooting commands. Here some of the SOAP commands and the debug command that I've listed that can be useful in the daily troubleshooting if you're experiencing any challenges with the SaaS applications. So the SOAP command like SOAP Cloud Express local exit, SOAP Cloud Express gateway exit applications, Cloud Express and the SOAP Cloud OMP Cloud Express detail. So SOAP Cloud Express local exit will tell you all the interfaces through which the probings are going on. So it means all the interfaces that has the NAT enabled will be the part of the probing, and it will show in the local exit what are the loss, latency, and jitter parameters over each link. So Cloud Gateway Exit will tell you that suppose if you have configured any VH or CH as a gateway for any of the SaaS applications, so if that parameter has been learned to the client side, so we can see this output by checking the SOAP Cloud Gateway Exit. So Cloud applications will tell you what all the applications are, and for each applications what is the best path that it is calculated and it has installed. So suppose so Cloud Express local exit, suppose in so Cloud Express local exit you have three interfaces having the NAT enabled, and the G0/0 is having the best parameter as per the other two interfaces. So in the So Cloud Express applications will install the G0/0 as a chosen interface for the SaaS. So OMP Cloud Express, we can check the Cloud Express SaaS application that is learned via the OMP in the case of the client gateway design model, and the same the OMP Cloud Express detail. And below are some of the debug commands that we can execute if something is not working and we need to check for the logs. So the debug plot the events that will tell you all the events in the same way FTM, RTM, OMP, that is for all the Cloud Express application that is coming via the OMP, and the debug OMP CXP level high is also the same for the OMP learned SaaS applications. So as I mentioned that there could be two types of kind of deployment where you have the client and the gateway model where the SaaS application is using the gateway as the exit, or you can have the DIA model where all the SaaS application can take the local exit from the branch router itself. So here I mentioned some of the things about the deployment model for the gateway exit. So in this deployment model, whether it's VS router or the CS router who is acting as the gateway will be working as the direct exit to the internet for the SaaS applications. Now the gateway router resolve the SaaS application address using the DNS request and does the HTTP probe to the SaaS applications and calculate the VQE metrics. So suppose you have one gateway or two gateways, both are configured as a gateway, and both gateways are sending the probe to the HTTP probe to the SaaS applications and calculating the respective VQA metrics. Now the gateway router will advertise those metrics via the OMP to the vSmart. Now it's the vSmart responsible. Now the vSmart, as which is acting as a control plane, will send all these details to all the branch locations. So all the branch locations which are configured as a node type client, because we have this gateway, so there should be the client which all are configured as a client, will install the SaaS applications, calculating the best path by adding the loss, latency, jitter metrics till the gateway and to the OMP CXP route that is learned via the vSmart. So here I've used some snippets from my lab, where I can show commands what to check and how to check. So if you see, this is my gateway router. This is the snippet from the gateway router. The Cloud Express is configured as a gateway. You can see the node type is gateway. I have used the three applications: Office 365, Amazon, and the Dropbox. But while checking with the Cloud Express applications, you can see the exit type is showing none. So the gateway router is not able to detect the exit interface, and due to which it's telling the exit type none. So it is not able to probe the SaaS applications. So here I enable the debugs, debug Cloud Express all, as I mentioned in the first slide of the debug commands. After enabling the debug, you can get the log in the directory, the var log temp log vdebug file. So here, if you see while checking the show log, I can see that the failed to look up could not contact the DNS server. So it indicates me whether the DNS is not working at all or it's not configured. So by looking at the configuration of the VPN 0 configuration, here the snippet is there below. You can see we don't have any configuration related to the DNS. So now I enable the DNS in the VPN 0. After enabling, we can see in the log that my device is able to do the HTTP ping succeeded for all the 3 applications. So you can see it's doing the HTTP ping for the Office 365, Dropbox, and Amazon, and selecting the interface G0/0. So now in the show cloud space, there was a 2 interface. Yeah, here you can see the show cloud space local exit in the right hand bottom side. You can see the snippet is the show cloud space local exit. There were the 2 interfaces, but for the troubleshooting, I configured one of the interfaces the wrong default gateway. So you can see for it's trying to, but G0/1 is showing the loss of 100% because it's not able to contact or not able to send the stripping over that interface because the default gateway was wrongly configured. So on the basis of this, the show Cloud Express application has chosen the interface that is G0/0 in the Cloud Express application output. So you can see the exit type is local. For the gateway router, its exit type is local. Now the gateway router will redistribute these parameters, the Cloud Express application parameters, to the OMP. So now while checking for the OMP Cloud Express, we can see that these all the parameters like Office 365, Amazon AWS, and Dropbox is redistributed to the OMP. You can see the originator is 2020 and the from peer it's telling 0000. It means it's locally redistributed. So these informations are getting redistributed to the OMP, and that will advertise to the vSmart. Not to be, as I said, it's the vSmart responsibility to advertise to all the spoke locations. Now on vSmart, while checking for the OMP Cloud Express detail in the right hand side, we can see that vSmart has learned the Cloud Express applications and also the metrics that has been advertised and where it's where the vSmart is advertising all these details. So originator is 2020, app name is Office 365, Amazon, and Dropbox. From peer is 20, and we can see it's advertised to peer, 2 column. We can see to peer. It's sending to the system IP. It's sending to all the VHs or CHs which is available in the network. So I was having the 4 devices. 10, 10, 10, 10, 11, 30, and the 40. These were the 4 devices that was available in the network. So it's advertising all the parameters to all the peers. Now, my devices in the network, I was having the SAS enabled for the branch side. That is only for the site ID 10, which is the 10.10.10.10 and the 10.10.10.11 as a peer. So while checking on the branch router, this is the branch 1, which is having a site ID of 10. While checking, I can see the branch is installed. The SOMP Cloud detail, I can see it's learned from the vSmart. We can see the from peer. It has learned and it's installed. And what all latency or loss parameters we are getting, that is advertised by the gateway. Now, while checking for the So Cloud Express application that is actually installed, we can see the exit type is gateway, and where it's learning from the 2020, which is the gateway. But the latency parameter, you can see it's 69, 68, or 67. It's reflecting. It's adding its own latency till the gateway. So the branch 1 is having around the 66 or 67 latency to the gateway, and this parameter which is advertised with the vsmart is which are advertised with the gateway is the latency of 2 or 0 or 0 whatever. So it's getting added to the latency which is there from the branch till the gateway. Now suppose if you have two gateway advertising different parameters, the branch will calculate its own latency to all the gateway, and it will add the respective VQA metrics. We can see the loss latency jitter from the gateway, and whoever is having the best path, it will install that one in the routing table. So that was pretty much from the gateway and the client and the gateway deployment model. So this is for the troubleshooting CR for SAS in the local exit. Here, it's basically the same. We have already covered all the troubleshooting commands, but yes, from the configuration point, we can see that we have allowed the allow local exit for all the three applications. And after enabling the debugs, we can see the logs stating that the HTTP ping is getting succeeded on the interface G0/0. On the basis of this, the So Cloud Express applications, it's installing that interface in the routing table. Now I will take you to the CURIS lab walkthrough. So CURIS multi-cloud walkthrough. So I mentioned this is the open link where you can use to create the free trial for the CURIS walkthrough. You can have the experience how we can configure it and how we can have the glimpse of how it looks like. We can use this one. I'm also going to use to demonstrate the same lab in this presentation. So below is the AWS deployment, the new architecture. In the new architecture starting from 20.3, we are using the transit gateway as a model on the AWS AWS deployment. So here we can see that the SD-WAN branches office are connected to the internet from there it's connecting towards the it will go to the cloud, which is the AWS. So in AWS we'll be creating the transit VPC, and further it will create the two CSR or the VH routers, and that will have the IPsec tunnel to the transit gateway, and the transit gateway will have connection to both the host VPC. And this is the old architecture below 20.3 where we are having where the TGW was not getting used. There we are using the VGW virtual gateway to each VPC host VPC where your applications are resided. So and that from the transit VPC we will be having the IPsec peering to the virtual gateway. So there were some limitations on the old architecture that you cannot transit VPC can only learn the host VPC subnet. You cannot add particular subnet if you want. Suppose if you want to add some routes which is not there in the part, which is not in the subnet of the host VPC, that cannot be learned on the transit VPC. So this model we can achieve via the TGW as a new model, where if you want to advertise some route over the BGP to the transit VPC, which is not available, which is not in the subnet of the any of the host VPC, still we can. Yeah. So now I will take you to the CURIS lab walkthrough, how it looks like. I'm just stopping sharing this one, and then we'll reshare again. Is my screen visible?
Yes, Nitish. Yeah.
Yeah. So here I use the same link that is given in the PPT. I use the same link and I created my I filled all the information that was required, and this is the demo version where you can have the glimpse, you can experience to configure the CURIS multi-cloud. So this is the sandbox deployment. You will get the access for the 2 hour that you can do whatever you want. So here we can see right now we have only one edge. Now we are going to deploy we are going to deploy the CRIS in the AWS infra. I set up for the AWS. So we need to first create the template which is going to attach. So there is already a template created which we are going to attach for the 2 devices on the AWS infra. So you can see it's already there. So you should be having the in 2 unused devices list in the devices. So it's already there. We can see that these 2 are not used. So now I'll go to the template and I will attach. So it will, as all the parameters in the template are the default, we need to configure it from here. So I'm taking the base internet, host name AWS CR1, system IP 101.100.1, site ID 100. So it will generate the pre-configuration which we are going to deploy on the AWS Azure infra. So here the configurations are ready. We can push it, but it will go to the done schedule state because the devices are not ready yet. Once the devices will come up, the device will get all the configuration from the template. So you can see this is the configuration that is going to get pushed. So let's go and configure it. So it has gone to done schedule because the devices are not online yet. Now we need to go to the CRI on cloud on ramp for multi-cloud. This is the page where you need to configure everything, your account settings, like how your credentials to the cloud, whether it's AWS or Azure or GCP, you need to fill the credential. So here you need to create for the account creation, you have to use this one. And this is account manager, what is already there. It's already, so as this is the demo account and it's a sandbox deployment, everything is pre-configured. We don't need to edit anything or change anything here. So this is the global setting that like what are all the CPUs will be there, what subnets we are going to use, what is the AS number that we are going to use. So it's already configured as a part of a demo. So we don't need to do anything here. So now first thing that we need to discover the host VPC, which is already there on the cloud. So go and click on the host VPC. As integration has already been done, I mean, we have already set up all the user credentials on the Vmanage page, so it's able to do the API pull and can fetch all the host VPC which is already running on the cloud. So now we can see here there are 3 it's showing. So we need to tag. So right now it's not getting it's not tagged. We need to tag it. So select it, tag. I'm just tagging the host VPC. So let's say eng VPC. Say add. So it's yeah, it's done. Let's go and do the tagging for another VPC. Okay, so we tagged the host VPC. Now we need to create a gateway. I mean the transit. We need to create the transit VPC, which will be act as the gateway for all the host VPC, and for all the applications which are hosted in the host VPC. So we did this first step, that the setup. Right now, as this is a demo, we don't need to change anything here, like the account creation or account management or the global setting. It's already pre-configured as this is the sandbox deployment. But in your setup, you have to go and fill all the credential in here in the first step. Second step, we need to discover the host VPC, as we already did, and we already tagged the host VPC. And the third step, we need to create the cloud gateway, that is the transit VPC, having the two CSR running, and we will be having the IPsec peering to the TGW in the AWS environment. So now let's go and create the cloud gateway. So it's asking about what name we can give cloud gateway name. Let's give uh, account name. It's getting fetched from the credential that you have already configured. It will fetch it. We need to select what region we are going, as our host VPC was in the US West region. We need to select the same US West 2. SS key will be leaving. It's optional. Now we need to specify the UID that we attached in the first place in the template. So we need to select both. Now I add. So this process is going to create the transit VPC. So it's everything is automated. It's going to create the transit VPC with having the two CSR on body. It will take some time to do it. So we need to wait for some time. In the same way, as right now I'm using the AWS sandbox. So we can use for the GCP, we can use for the Azure, we can create. Now this can be connected, interconnect using the Megaport or the Equinix that has been demonstrated by the Rama, that we can use those one to interconnect all this. So right now I'm using only one infra to just demonstrate how the workflow is. So now we can see the creating VPC. It's done. VPC has been created. This is the transit VPC. Now creating the CSR. It's not I'm going to deploy the two CSR in that VPC. So basically, we are extending our SD-WAN fabric from the branch to the gateway to the cloud, where customers' applications are hosted and they want the reachability. So done. Our two CSR has been created on the AWS infra. Once now, if we go to multi-cloud, we can see that it should be. Oh, it's going to take some time. Just wait. Good. I think I need to check.
Yeah, Nitish, I think it's going to take some time. Yeah.
Yeah, it's going to take some time. I need to check what gone wrong.
All right. Sure. So, do you have any other thing to cover, Nitish?
No, I was going to cover the complete. So the last thing that
Okay.
was
Go ahead.
left, that after once the CSR will come up, we need to go to the intent management where we need to do the connectivity from the transit VPC, because from the transit VPC to the host VPC. So by doing so, it will create the IPsec tunnel from the transit VPC to the TGW, and the TGW will have the connected to the host VPC. So that will do the mapping, and this step will take some time because creating the peering on the AWS cloud, it takes some time. It will take around 15 minutes to get complete. For this one, I need to check what gone wrong with this sandbox setup. Here, Guru, I think I need to check if we can stop here. Okay, I can see it's up. I'm just resharing. Is it visible now?
Yes, Nitish. Go ahead. Yeah.
Okay, so yeah, it took some time because the AW Vmanage does the API polling to the respective cloud hosted by the AWS Azure, and it fetches the output, and then it will show on the Vmanage GUI. So maybe that time the device was not having the control connection, was not reachable, or the API polling was not successful. But now I can see it's telling the one reachable device. One device, it's still showing not reachable. Maybe the control connection is not set up. So in the main dashboard page, we can see 3. So it should be coming in some time due to the API polling. Yeah, we can see both the devices are reachable now. Now we need to go and create the connectivity between all this. So we need to go in intent phase management, and here we need to do the mapping. So as we already created the ENG VPC and the finance VPC, and this is a VPN 10. So we need to click here, edit, and we need to make the connection. Here the dual connection. Yeah, we need to click on save. The mapping ability, so it's going to create the IPsec peering from the transit VPC to the TGW, which got spinned on the AWS. So this process is going to take some time. Meanwhile, we can check all the things like the BFD from the branch. So this was the one branch, and these 2 devices got spinned up on the AWS side, and it's reachable now. Let's log into the branch, and we can see the BFDs are up. So we extended our SD-WAN reachability. So we extended our SD-WAN infra till the AWS cloud. So we can see the BFDs are up with both the system IP 1101, 1102, and we should be learning routes. No, routes will not come until the mapping has been getting set up. So right now it's not learned. Once it's done, then we'll see the routes coming from the AWS environment. So it is still in progress. And it's going to take some time. I hope it's okay, Guru sir.
Yeah, we're good. Yeah. Thanks, Desh. I think we kind of went ahead and took more time, like 20 minutes more time than scheduled one. Thank you so much for your time, and we will meet again on 6th December. That's the day 3 next Monday with a lot of other topics. Thank you so much for your time.